countries across the world. And I can understand there are about 30 people who are presenting their papers or talking on this convention, which I think is a path-breaking sector. We all know that the pandemic has been pretty bad for everybody, but I think it's not bad. It's actually good. It's made us rethink. It's made us understand who we are. It's made us realize that this planet is our home, no doubt, but we are only tenants. The owner of this planet is Mother Earth, and we've got to live by her terms and what she denotes as life as we could take it. And as such, transportation is something which is actually inherently one of the key factors for how and why we pollute this planet. And to put it in a nutshell, when I was a kid, we knew about Jetsons and comics in terms of drones. In fables and fantasy, we knew about Pegasus as a flying horse. We all know that man first took to horses to go faster than what he could walk or run. And then he translated that into horsepower, into mechanical energy and to motion. However, it's important to understand that just like in our body, we have arteries and veins and capillaries. And within these flow our red blood corpuscles, which deliver energy, which deliver nutrients. And on its way back, it also delivers oxygen. And on its way back out of the system, it takes out all the oxidants and the pollutants from our body. Unfortunately, while in the world, communication is through highways, roads, and alleys or whatever. And we have cars, trucks, and buses and two-wheelers that transport people, transport goods. And therefore, like red blood corpuscles, they give us what it needs to make the economy run, people to live. However, the downside is that conventional transportation pollutes the planet like none other. And what's important to understand is that the roads that are made and built are polluting from the word go. From the time you take out the materials to make a road, transport those materials, to dig for the road, making earth-moving equipment, etc. You clear trees and foliage in order to make a road, right? And then you lay the road and then you pollute the planet, all right? So you're doing the reverse. Now, I feel that drones is something that's going to completely change that reality. It'll take a little time, but given supercomputing now, given quantum computing, which has now come out, we will find developments very fast. So I wouldn't take much more of your time, but just to say that man's desire, eternal desire, is to go faster, go further, to discover more, and to fly, right? So there's a combination of both a car, a horse, and a plane in the form of a drone, which is the dream of any human being. So nothing can stop this development. Nothing can stop this from going forward. And I'm thankful to Cabotics and Ruchi, etc., who have brought about such institutions who can collate this information. And we've been discussing also on how we could take this forward. Because it's important to understand also, I must say this right now today in this forum, that while we must popularize it, make it acceptable, make it understandable, but we must understand it has to be done in a very safe way. We cannot fool around with this technology. It's essentially aviation. And the reason we all take to an aircraft and we fly is because it's safe. And why is it safe? Because Federal Aviation Authority ensures that all the technologies and the planes have backup systems. There are 3 backup systems. It does make planes expensive, but it makes them very, very safe. So we must understand this, and we must honor this, that it is something that we owe to society, or to every human being, that we shouldn't hurt anyone or maim anyone by this technology while it is inevitable and to go forward. I thank you all for coming and participating in this convention. And thank you, Ruchi, once again for inviting me to inaugurate this global convention. Thank you very much.
Thank you very much, Kapil sir. I now invite Mr. Vivek Kulkarni, who is a professor at Thakur Institute of Aviation Technology. And they have supported us in almost everything that we have been doing and will be doing further. Mr. Vivek Kulkarni, let me see where I am. There you are.
Hello.
Hello.
Yeah, very good afternoon to you, Dr. Ruchi, and the distinguished guest over here. It's not my area to speak on, but definitely it's a very developing area now, and drones are required in the industry now. Indian industry is also gearing up for the drones. Even the MOCA has given us the green signal, and most of the fact that young students are very much inclined and interested toward this area. So definitely it is going to help out in near future, such kind of conferences, and various delegates over here, various dignitaries, those who are having enough knowledge about this system, they are going to speak today. And I will not speak much, but definitely we would like to hear from them, and I'd like to have many more questions to them. So I can get the knowledge from them. And Thakur Institute of Aviation Technology is always supporting such kind of conferences. We want to promote aviation sector itself in India to grow very high. So definitely drone is also the area where we are looking into it. We are going to start the drone training institute in our campus. So I would request if anyone is volunteered from these speakers, they can contact us, and it will be very much helpful for us to develop a very, very good institute for the drone. And definitely we can look out more conferences over here. Last year we held in hybrid mode, but this I could not understand why, because some time constraints, we are into online mode only. So definitely, Dr. Ruchi, please take care so that we'd have one hybrid mode event, so that physically also we'll see all the delegates in our institutes and we can talk with them. So thank you very much to inviting me, and also as a Honorable Secretary of Aeronautics Institute of India, Mumbai branch, I welcome you all delegates over here to speak. And this from ASI also, we are going to have various events at our campus. And recently we are into aerosports also. We are going to organize in the month of November. If some of the volunteers, they want to take part in that aerosports event, because now in aerosports, drones are also included. So now in the aerosports in the month of November, with the help of MOCA, we are going to have a good event at Vasi. It will be physical event. So those who are there attending this event, they can contact us and support us for this drone event, which will be physically over there. Not only drone, we are going to have aero modelers over there and kites flying over there. And this event will be for physically for the young kids. So I would request those who are interested in this area also, they can come forward and contact to ASI Mumbai branch. We are going to hold very soon this event in the month of November. So thank you very much, Dr. Ruchi. I will hand over to you. Please carry on. I am going on listening, and I will ask many more questions to the delegates over here.
Thank you very much, Mr. Vivek. Now I request, I would introduce first my volunteers for the day. We have Satvik Vashishta, who is a student in Bangalore. He is absolutely interested in drones. He will be ensuring that he introduces the speakers. He takes a lot of notes and he picks up the intelligent questions that you're asked. So he is a very picky picker. So make sure that all the questions that you ask are very intelligent, very interesting for the even speakers to answer. Do that. And we also have Nalule Mary Sandra, who is joining us from Uganda. Nalule, can you put on your video, please? Sandra? Hi, Sandra. So we have Sandra and we have Satvik, who will be volunteering. And I request Satvik to take over. Who is taking over, Satvik or Sandra?
Me, Satvik itself.
Yes, so Satvik will take over the conference, and all the best to you all.
Um, Good afternoon, or good evening, or good morning to everyone present in this call, to all the respected delegates over here. So, introducing myself, I'm Satvik. I'm from Bangalore, India. So, I'm in my first year of engineering, and I'm part of my college's UAV team. So, we are a team that take a lot of interest in building our own systems and participating in a competition that's held in the USA every year. So yeah, that's why I was very interested in volunteering for this conference, and I would like to thank Ruchi ma'am, Ruchi ma'am, in giving me this opportunity. Moving on, I would love to introduce you our next delegate for this call. That would be Mr. Gary Vermaark. So he hails from South Africa, and he's going to speak about integrating. He's going to speak about integrating drone logistics supply into the systems. And to talk more about him, Mr. Gary is an Africa-focused advisor, consultant, and ecosystem developer focusing on renewable and sustainable energy, logistics, mining, and mobility. So, Gary, sir, without further ado, I would love to hear what you have to say. And if anyone has questions regarding any of the delegates, please do feel free to ask them in the chat. Thank you. Taking over, Gary, sir.
Hi, good day. Apologies, I am in transit, so unfortunately I've had to make a quick plan here, but the presentation is here, I'm here, and looking forward to talking to everybody. Thank you. Okay, I just want to share the presentation.
Can you try it?
Can everybody see the presentation?
Not yet.
No, sir. We can.
Sorry?
No, we cannot see the presentation.
Can you just see what's going on?
We could see your phone screen.
Yeah. Can you see my home screen now? Okay.
Yes.
Okay, so let's get to the presentation. Okay, is now visible.
Yes.
Okay, I just want to try and get it full screen. Okay, welcome everybody. What I'm going to do today is talk about the drone logistics ecosystem, which is a free global multidisciplinary, what we call quadruple helix network of companies, universities, public and investors, with the aim to stimulate innovations, collaborations, and standardization in the drone logistics industry. Most of the companies in the industry are early stage startups with limited access to funding, manpower, and expertise. So what we're trying to do is create that forum to bring these companies together and as a group to be able to promote both the drone logistics ecosystem, but also promote investment in the industry. And I think most of us are aware of the drone delivery market. We have everything from the basic infrastructure, we have operators, and we have people that manufacture the equipment. And what we've tried to do is bring everybody together. I think what people forget, if you look at the drone, the market size for cargo delivery, it was about, advanced air mobility, and that's now taking, was about 528 million in 2020, very small still, but according to Deloitte, it's expected to reach 58 billion by 2035. But we need to look at it in a much bigger context. The drone logistics forms part of what we call the greater global courier, package, and postal delivery industry, which last year was worth 300 billion. And we see drones not only competing with, but also complementing other sustainable forms of delivery, from your courier bikes with a guy pedaling to big, massive cargo aircraft, ships, etc., moving packages across the world. Typically a DHL, Amazon, any of those companies, but also we see a lot of collaboration between both the big guys like DHL and the small guys. So we see the drone industry being very much a localized focus. On the SUAS side, I'm not going to go into the big aircraft like the X-Wing caravans and aircraft like that are being developed as drones, as uncrewed aircraft. What we're looking at more is the SUAS side, and we see very much like companies like DHL outsource the last mile delivery to smaller companies. We see that drone thing, because I think it's also about local knowledge, local expertise, and local acceptance by communities. I think what we've seen is with the COVID-19 pandemic is that the pandemic has had accelerated the expansion of the drone delivery market for short range and payloads of 1 to 12 kgs, really around things like delivering medicines, delivering vaccines, but also, as Manna have been doing, helping, and Wing have been doing, is delivering groceries to people that couldn't go out, old people, people with comorbidities, etc., so that they could be taken care of without putting themselves at risk. We really, as the drone logistics ecosystem, our mode of operation is really around bringing together all the bits and pieces: education, standardization, networking, consulting, innovation, sponsorship, etc., fundraising, and to create something that is viable, but also promotes the industry from the smallest company to the biggest company. And we have, in the year that we've been running, since the 7th of July, 2021, we've managed to grow the drone logistics ecosystem to 46 companies in 21 countries. And if anybody counts, there's 45 there. We were fortunate enough yesterday to welcome Switzerland's Logistic into the drone logistics ecosystem. So we grew to 46 this week. And really what we see as the drone logistics ecosystem is a one-stop solution for the industry and for the customer. So basically broken down into all of the various components that make up an ecosystem. And one of the companies that was one of the founders is a company called Ego Design, together with an Australian company and a French company, formed the drone logistics ecosystem. And those two companies were Free Space Operations, who have built a very, very good drone. and the other one was dragonfly pads in France. So what we see is the drone logistics ecosystem. As I said again, it integrates into that global package, parcel and courier delivery industry. And we see items moving from the factory, the first mile, same day. That could be by truck. It could also be by drone, depending on what the item is. I mean, if you're sending a $1,000 iPhone, probably fly it, especially if you're in a country like South Africa, where I think most of you have seen on YouTube the case of where somebody attempted to hijack a truck carrying the high-end smartphones between a warehouse and a store. So, you know, and that we see those items moving to a sorting station. From there, it would be moved into, packaged into, for example, in its box still. And we see the whole idea of having a standardized cargo box for a drone delivery is that there is no opportunity for people to touch the item. The item is securely in a box. That box is locked with electronic locks. Each box is completely traceable. So at any point in time, we know exactly where the box is. And those boxes would then be 300 of them would fit into a standard container, such as the LO3 container, for example, LD3 container, that's used all over the world on a lot of the major aircraft. From there, it would be flown hundreds, thousands of miles to another sorting, and then end up in another sorting station. From there, it could go by truck to a vertiport, or the vertiport could be next to the station. And then the item could be delivered, same day delivery. And it could be delivered by drone, it could be delivered by bicycle, motorbike, whatever, to your office. Just a little bit about who the people are, the key people in the drone logistics industry. It's Dr. Ali Jahanshahi, who is the Global Executive Director. We have Rick in Europe. We have Ryan in North America, myself in Africa, Tiago in Brazil, and Asa in East Asia, based in Japan. And what we've been busy with, and this is really looking at the things, we've been working with with various companies on a first proof of concept campaign, which was 6 months with 5 companies on 4 continents. And it was to develop and test and promote the whole idea of this. Starting with firstly Rangus, which is the market in the region Ile-de-France. And we did a program doing over 50 deliveries. That was with dragonfly pads. That was done last year. Then we have another project, Redcliffe Light Tech, which was moving samples, companies involved with Sky in India and SAW. Then we also worked with Alpha Swift Industry in Tramigo in Malaysia. And that is, we are running over 400, to conduct 400 hours or 16,000 kilometers drone testing over a period with drone robotics zone, supported by the Ministry of Science and Technology in Malaysia and sponsored by DHL. And then in Australia, as I mentioned, one of our co-founders of the DLE was Free Space Operations. They are running a number of tests on things such as ship to shore, 5 to 50 kilometers, specifically with regard to maritime applications. And then in the USA, Ego Design together with Bakari and Tramigo are running a proof of concept project in Chicago and across other cities in the USA. Started in February for 6 months for drone delivery, covering distances of around 10 kilometers. And that brings it to an end. If you got any questions, I would be more than happy to address them.
Thank you, Gary, sir. I hope it was a very nice presentation, and we got a lot to learn from the presentation as well about the drone logistics and the delivery of couriers through drones. It's very interesting, in fact, for me as a student. If anyone has any questions to sir, please do put it in the chat box.
If anybody is interested in joining, they can contact myself or Ali Jahan Shahi via our website, which is www.dronelogisticsecosystem.com. And membership is open to any companies active in the drone logistics industry. It's also open to universities and other government and private institutions active in the drone logistics industry. I see we have a question from Ashwani.
Yes, can I go ahead? Can I pose my question?
You're unmuted, sir.
Sure, please do.
Hi, Gary. Nice presentation. Thank you. Now, in your area where you are located, what are the rules governing the drone operations? As you know, in India, we had begun with no permission, no takeoff protocol, but that was withdrawn soon after because it was not workable. And now we have a zonal system. We have red, yellow, and green zones. And depending on the zone, the rules are defined. So in your area of influence where you are, what kind of rules are there governing operation of drones? Thank you.
Okay, I think, well, as the drone logistics ecosystem, as I mentioned earlier, we're in different countries. So you know, it's quite difficult. For example, in South Africa, allowed to do deliveries or you know, B-class flights over urban areas, but we are allowed to fly up to 25 kilometers if you have the right license, for example. So each country, and the United States has its own rules. So it's very difficult to say, you know, each country, and it's on a country by country basis.
Okay, but can you, in particular, if you are aware of, let's say, South Africa, can you just detail what kind of, I mean, my concern is that how is the safety of the other, flying objects like aircrafts, etc., maintained by the, like there was an incident at Gatwick Airport was shut down for, I don't know, 36 hours because of suspicious drone activity, and millions of, dollars were lost. So many flights were cancelled. So to prevent such an eventuality, what kind of a safety protocol is there? That's all I wanted to know. Whichever place you are aware of, you can brief.
Okay, I think, yeah, look, I think there are certain drones have geofencing, so they can be kept out of, areas like airport approach. In certain, there are, countries are investing in a lot of money to keep rogue and what I call idiot drones out of those areas. I think, professional commercial pilots, I think, know the rules. They won't, they will notify the local civil aviation authority that they're operating in an area. Around airports especially, it's a requirement that you notify the control tower at the airport that you are flying somewhere close. You have to maintain your distances. If you need to, for example, drones that are used specifically for airport-related work, they would be scheduled and allowed certain areas to operate by the control tower. But I think it's, I think one thing we must remember is that generally under EU, it's 500 feet. They've got to operate under 500 feet and 400 feet in the US. The big problem is always where you have emergency aircraft, for example, like sort of EMS helicopters and things, that air ambulances that have to land, and that has to be managed. And I think the general rule would be, I think, for any drone operator, is the moment that you see air ambulance or police helicopter, for example, or military helicopter, is that you bring your drone down immediately and land it. That's sort of one of the basics that I think we've got to stick to. But again, they are, I think, and a lot of people will point it out, is that drones get a bad rap, but there are a lot of general aviation pilots out there globally that don't fly with any form of remote ID, that very lax in filing flight plans, etc., that tend to fly too low over areas as well. There was an incident here in South Africa where a group were doing work for a farmer, surveying crops and that with drones, and a crop duster pilot decided, well, he was just going to fly over and start dumping pesticides over the land, even though he had been informed that this work was carrying on. So we do have that kind of thing. So it works both ways. But I think the trick is that as pilots, commercial pilots, you've got to obey the rules and do what is necessary to keep everybody safe. And
thanks, Gary.
If you look at some of the sorry.
Thank you, Gary, sir. Actually, we have another question from Divyansh for you. I'll direct you the question over chat, actually. Yes, sir. I've sent you the question to chat.
Okay, let me see if I can get to it.
Yeah. Can you see it, or do you want me to say it out loud? Even that is fine.
Okay.
You need to say
sorry,
the
I
question,
have to
Satvik.
respond to that
You need to
offline.
read out the question.
With the people that are involved in
Okay.
in the various things with regard to what communication channel was used. I don't have that technical detail with me at the moment. Sorry.
Yeah. Thank you, everyone, for the questions. I think we can now move on to the next delegate in this conference. I'm sure everyone had a nice time with Gary, sir, talking about drone logistics in this conference.
Thank you. It was a pleasure talking to you, and good luck for the rest of the conference.
Thank you, sir. Let me introduce you to Mr. Simon Masters. Masters, who's here to speak about drone, who hails from United Kingdom, and he's into UK research and innovation. And he's here to speak about developing a drone ecosystem to deliver key public and emergency services. Speaking some more about him, he's a part of the Future Flight Challenge. That is a 300 million pound program, part funded by the industry and the UK government, using new classes of electric and hydrogen and autonomous vehicles. Simon, sir, it would be great if you could take over from here. You're muted, sir.
Thank you. Okay, that's sorted now. Thank you very much. Good morning from where I am. Good afternoon, perhaps where some of you are. I'm Simon Masters, the Deputy Director for the Future Flight Challenge, and it's a great pleasure to have the opportunity to speak with you today. I do have some slides. I will try and share those now. So hopefully those will be visible to everyone. So yes, thank you for the introduction. I'm going to talk a little bit about the Future Flight Challenge program, what we are doing, and where we are going in the future with our drone activities, and really highlighting the opportunities that we're creating in the UK, but also the opportunities we are seeing for global partnerships and global collaboration. We're very much aware that we can't do all of this on our own, and we very much welcome your attention to this morning. So quite a lot has happened recently in the UK to do with drones. We've had the government's drone ambition statement has been issued, which sets out the government's priorities for the use of drones. And we've also had a report from PwC looking at the economics, the business cases, and some of the predictions of how the industry will look in the next sort of 5 to 10 years' time. And all of that, of course, continuing our program, which we launched back in 2019 and will now run all the way until 2024. So we have 2 more years to achieve quite a lot of work, and I'll go through some of that now. So there we go. So the Future Flight Challenge, we are addressing mainly what people are mostly calling the third revolution in aviation. So aviation has quite a short history by many standards, over just over 100 years perhaps, but we're seeing some big changes now, particularly the introduction of drones and other autonomous flying vehicles, so that they're really going to, as we see it, transform how we move people, how we move goods, and how we deliver services in the future. So what does all that mean for the public? It means many things. These are just some examples. So it could mean faster medical deliveries and better capability to respond to disaster relief scenarios. It can make inspection and maintenance tasks much safer and cheaper, and it can be more inclusive. So we can find ways of transporting people who are less mobile and less able, all the way through to last mile deliveries, which is quite a common thing we talk about, and the way that we can new forms of green aviation can help connect rural economies. So our program is very complex and very broad, but in the center we have these different vehicle types, but actually that's not where the main focus is. The main focus is in this sort of ring around the outside, and what we're aiming to do is to build this ecosystem that these vehicles will operate in. For us, just simply funding the technologies themselves does not answer the question. If you have a lot of new technology that you can't use, then you haven't really succeeded. So we need to address some or all of those items you can see. I won't read them out, but these are some of the other areas that we're looking in, focusing on things like regulation, on infrastructure, and communication systems. So we have a roadmap, we have a vision statement that sort of looks out to about 2030, and we've used that to try and guide what we're doing and to really help challenge ourselves, but also challenge industry as to how these new vehicles might be used. This is just our view. We are very open to be challenged on this. There may be other people with better ideas, but these are some of the scenarios and some of the use cases that we see for the future of these sorts of autonomous flying vehicles. As I said, because this is quite a new industry, we can't just focus on the traditional aviation and aerospace industry. We need to bring in people with skills from across different sectors, such as infrastructure, civil engineering, for example, for vertiports. We need people who know about software and communication systems. So all of that needs to be brought together in order to achieve what we want to do. And of course, we are trying to put people at the center of this, both in terms of the societal benefits that people, you and I, might get from the services these new vehicles provide, but also to try and understand some of the social science aspects. What will the public think? How noisy is too noisy when it comes to a drone flying over people's houses? You know, what is the public perception going to be of introducing these new technologies? And bringing that all together, and I know that the text is very small here, but this is just really illustrate. We try to bring this all together into a sort of a series of concepts as to how these drones, for example, will fit into sort of a modern integrated city and in a modern integrated transport system. And I think this is just a sort of a repeat of what I've said, so I'll skip over that one. So what have we done so far? So we've funded 48 collaborative research projects in what we call phase 2. Most of these are now finishing. They cover a really wide range of projects, and some of them were very successful and as you can probably see, were picked up by the news media, and that was great. And we were very, very proud of what was achieved through those projects. Again, pictures perhaps tell more than words. So these are some of the ideas and some of the aircraft that were developed and some of the services they provided, including the one in the bottom left is one of my favorite ones. It was a trial with a drone dropping an emergency defibrillator on behalf of the ambulance service to look at if you could deliver sort of vital life-saving equipment like that safely. It does have a parachute attached. That was the main concern, actually, was to make sure that that when you're dropping things near to people, near to casualties, that you don't cause them any injury if it lands in the wrong place. We also were able to use our funding and our position as a government agency to support the UK government's COVID-19 response efforts. There was a tremendous interest from the drone community in the UK to try and help out where they could. And so we did a number of activities, really starting to demonstrate how drones could be used to deal with very, very large sort of challenges that the UK and indeed many other countries were facing at the time. There was a number of firsts that we managed during that period. We did some public perception studies about carrying drones and for medical delivery. We were able to do the first, certainly in the UK, transport of chemotherapy drugs by drone. We delivered COVID test kits offshore to ships so that ships didn't have to come into harbours and potentially have people interacting more than necessary. So we were able to fly those test kits out to ships. And we also received clearance to fly 2 of the COVID vaccines that were cleared for use at the time by drone. I'll say a little bit more about that one. This was a project that we were very proud of. It was in the southwest of the UK, in Cornwall, and was operating out to the Isles of Scilly, which are about 70 nautical miles off the coast, and islands that are reliant normally on boats to provide their mail, to provide their medicines, and this was obviously more challenging during the COVID period. So we managed to do some working with the Royal Mail, who not only deliver mail but also deliver medical supplies to these islands. We were able to use a drone to fly completely autonomously from the mainland to these islands. And then a number of smaller drones were then used to fly between the different islands. And this was the first time this had been approved. So we had to do a lot of work both with aviation regulators and with health regulators to ensure that they were happy that carrying the COVID-19 vaccines by drone was safe and that it wouldn't affect the kind of efficacy of the drugs themselves due to temperature or vibration. So that really started to show what is possible using drones in this way. This kind of takes us up to where we are today with our program. This is a slide my boss always likes to show. In the middle, we have the funding that we give for the R&D projects. What we do like to say is that around the outside of that, there's all kinds of other stuff that isn't actually as immediately obvious. It's not about giving out large sums of money to businesses. It's not about technology. It's actually about creating those wider systems. So it's working with regulators, working with the Met Office to look at what weather services drones may need. It's looking at standards, and it's looking at things like public engagement. So this is just really to show that whilst we talk a lot about the technology, and that's what excites and inspires us, there's a lot of other work that goes on to try and create this kind of future system that drones will operate in. Having said that, this summer we announced another 17 projects, which were announced by our then Secretary of State. He is now for business. He's now our Chancellor. Kwasi Kwarteng announced these new R&D projects at the Farnborough Air Show this summer. There's quite a lot of information here. I just want to pick out some of the key things. For us, we wanted to challenge these projects to be even more ambitious and to actually showcase what drones can do by almost exactly 2 years' time in September 2024. We want them to demonstrate the full service that they want to deliver as much as possible, as much as regulation allows. So they are working with a lot of end users, and many of these are public sector organisations. So we have the National Health Service in England and in Scotland taking part. We have work with the Foreign Commonwealth and Development Office and the Ministry of Defence, looking at humanitarian aid and disaster relief programmes and how drones can support the work that UK agencies and the Royal Navy carry out in delivering disaster relief to countries all over the world. I think I've already said that. I'll skip over that one. So again, some photos to show this. So there is a really wide range of looking at the applications of drones. So some of it is about infrastructure inspection in the bottom left, power lines, things that can be done more safely by drone. There is increasing focus on using drones to support maritime operations. And actually, interestingly, in the middle photo, forest fires, and we'll say I've got a short video clip. We'll say a bit more about that, but that's to say that's not something that's historically been important in the UK, but is actually in the recent heat wave that we had, becoming increasingly of concern to our fire and rescue services, and actually we may start to see as temperatures rise in the UK, increasingly issues with wildfires across some of our more rural areas. We are working with the regulators. It's one of the kind of unique features of our program is we're working very closely with the Civil Aviation Authority and working with regulators. Regulators working with R&D organisations is not that common, and it's certainly been a tricky relationship for us to understand. It's very easy to blame the regulators as the ones who stop you doing what you want to do. I think we've got a much better understanding having worked with them now. So really the tough job that they have in clearing, beyond visual line of sight operations and allowing drones to carry chemotherapy drugs, all the sorts of things that, excuse me, that companies want to do. We're trying to work with the regulators so that they can develop their regulatory frameworks in parallel to the technology development. And one of the areas where we've done that is in the carriage of dangerous goods, or DG as it's called on here, by drones. We did this during COVID-19 as a starter, but really started to look at things like what sort of container do you need in your drone, and what standards does that container need to have so that you can put any sort of dangerous chemical, a vaccine, a chemotherapy drugs, whatever it is, and you know that that will be approved by the regulator, and you know that it will be safe. So if there is a mishap with the drone, that these chemicals will not escape into the local water systems. So that's a key piece of work that we've done, and that's been really well received by industry. And just as a quick example, these are some of the things that it covered. So looking at things about approved packaging and whether that could be approved in the UK, whether it could be approved globally, so that if some of the operators are working in other countries, such as in Africa, Malawi, some of our companies want to work in there, they will be able to use the same standard of containers. Also things about what level of training people need to unload packages from drones. It sounds really simple, but actually there's a huge amount of work needed to, or thought needs to go in terms of skills and training for individuals who may end up having to unload, potentially dangerous chemicals from drones. I'm going to finish with a quick video. This is from one of our new projects. I hope the sound works. There are subtitles if the sound doesn't work very well. This is one of our new projects that's starting this summer, and it hopefully will explain itself, and hopefully will demonstrate why we're so excited about the future. I think once was enough. So yes, I think I'm pretty much out of time. So thank you very much for your attention. If there are time for some questions, very happy to take those now. I will just stop that sharing. There we go.
Does anyone have any questions to sir? I've unmuted you, Vivek, sir.
Hi,
Yeah,
Simon.
just a minute. Yeah, just a minute. Hello. Yes, Simon. Mr. Simon, it was excellent presentation from your end and a video also. I would like to know about something about Green Revolution project. What you mentioned. What's in your idea how the drones are going to help us in Green Revolution area?
Sorry, I think I had a small connection issue when you were talking there. I don't know if you could just repeat the last bit of your question. Sorry, I couldn't quite hear that.
Yeah, I want to know about how Green Revolution you are going to build up in the drone projects. You mentioned something Green Revolution.
I'm struggling a bit. Sorry, if you're able to put that in the chat, I can
I'll
try
put
and
up the
answer
chat
it.
then. I'll put up
Thank
the
you.
chat.
Sorry, it's probably a problem at my end. So sorry about that.
Okay. No issue. I'll put up in the chat.
Thank you. Happy to take any other questions in the meantime, or I'm sure I can try and answer them in the chat if that's proving. Okay, sorry. Yes, I can see the question now. Visual navigation is good. I think people have a lot of different views at the moment, and we're working with quite a lot of different companies, and they all seem to have different opinions as to whether visual navigation is better than LiDAR or any other system. I think in the next year or so, I think that people are going to do a lot of flying, and they're going to do a lot of experimenting and try and, I guess, decide for them what the right system is to use. I'm not sure, and I'm not an expert in those sorts of systems, but I think there's a lot of different approaches, as I said, being looked at, and I think just by doing more of the flying, more of the testing that we've got planned, I think they will probably decide what the best solution is, and it might not always be the same solution for the same area of operation, depending on where you're flying. But yeah, no, it's a very interesting question. And I think it's sort of, you know, we've sort of shown that the basic operation of these drones and what they can do, and then the next step is, you know, as you want them to operate beyond visual line of sight across longer distances, you know, then you have to start looking at the navigation systems and try and decide what is right for the kind of missions that you're undertaking. So the question on the use of drones during COVID. So it was done for two reasons. One of which was a lot of during the pandemic, during the lockdown period we had in the UK, a lot of companies were not able to work. They had to sort of almost shut down their businesses, or they had no customers. So there was some government support was provided to businesses to allow them to keep operating. And as part of that, we sort of challenged industry to say, what could you do to help what the government's doing with the pandemic? There was a particular then approach from some drone industry groups and some trade bodies to say, actually, as a drone industry, we think we can help the government. We think we can do things. What it meant was we actually did things a lot quicker than we would have done. And often this is what happens in a crisis. So regulations can be changed more quickly. There is much more appetite to take maybe some more risks, if we can say it that way. Obviously, we don't like to take risks in aviation, but to do things more quickly, to have a more open and innovative approach. So we looked at drones were being used for, I say, inspecting assets, so infrastructure, power lines, that sort of thing, that really got started through that, and the use of drones to deliver things, to communities that were relying on ships or larger aircraft to deliver things. Those services were reduced during COVID, partly because a lot of the crew who would normally operate those ships were sick, so they couldn't run the boats some days. So we started to look at using drones to deliver, firstly, their mail, which is obviously important for social reasons, but then delivering medical supplies and delivering COVID test kits, which otherwise would have been quite difficult to deliver So most of the work was done in the more remote areas of the UK, so areas that do not have the same roads infrastructure as the mainland does. So that's really what started, and I think we've sort of all acknowledged that it might have taken a lot longer to make those sort of make those developments if we hadn't had the pandemic and the kind of almost the need to do these things and the clear opportunity to demonstrate, how drones can reduce people, the interactions between people, which we were trying to limit, obviously. So you can have something that turns up from a drone and you can unload the package yourself, or your COVID test kit you can take out the drone yourself, then you're not interacting with another person. So you reduce the transmission.
Thank you so much, Mr. Simon. That was a delightful experience of your slides and all the innovative tech that you do at Future Flight. Myself being a student, I'm really interested and excited in seeing what you have done, all those fixed wings on the slides, flying so high, and such good technology. Thank you so much for your time.
Thank you. Thank you.
Yeah. Yeah. So moving on, next we have Mrs. Amruta from KSOA. She's the sales team manager, and she's here to speak about drone software, drone data management software, especially it's called ARU, which she's a part of. And she's a very forward-looking and energetic individual. She joins the drone industry as a sales team manager, and her goal for this event is to connect with more like-minded people here. So I'm personally very interested in what you're working with, because I've used Mission Planner, QGC, and all such these softwares for controlling my own drones and our team's drones. So I would love to see what you have to say. Please take over.
Unmute. So thank you, Satvik. So hello, everyone. So I'm Amrita from KSOA, and thank you for joining in. So now I'll share my screen. Are you able to see my screen?
Yes, ma'am, we are able to see it.
Maybe you can put it in the presenter mode. And do it like a slideshow.
Yeah, 1 second. Now it's okay?
Perfect.
So we are a young drone startup company. So we are a drone data management. So actually drone data can make a big change. And I'm lying with a big confident team, and I would like to share about a few things about for a drone technology and as well as for a sustainability. And we have divided our thoughts into two sections, like a drone technology and as well as sustainability. See, sustainability. Sustainability, the word itself, it is having a power. And everybody has having their own form of sustainability of thinking different forms. And also we are having few questions we'll think, like what would be the questions, like from whose viewpoint, and what is sustainability, what is sustainable living, and what could be the economic sustainability, and what is environmental and also social sustainability. Is being sustainable in my self-interest. See, according to my viewpoint, so what the thing is, so I'm going to explain now. So it being like a larger perspective. See here, this image we have got in a Wikipedia. See, actually now I'm in a right way of my presentation. And instead of giving a product demo or else giving a boring sessions, so we are planning to give an idea. And here you can see here there is a circular form of a sustainability. And before that, the sustainability, the word derives the ability to be maintained at a certain rate or a level, and the sustainability of economical avoidance of a depletion of a natural resource in order to maintain an ecological problem like a pursuit of a global. And like a global environmental sustainability. And here we can see like a circular form, like a social sustainability, environmental sustainability, economical sustainability. And here there is a 3-pillar and roof for the sustainable. So, and also we are having an ideas. So that is the ideology that we have made. So like it has been like a case study of a drone technology for a cities, and that is for a Newton Kolkata development, and we have done that. And this drone technology development, so it is been like a specifying that this is what idea we are going to give. And the second idea is a sustainable finance with monitoring outcomes by drone technology. And the third is the ideas like a city adapt an AI powered by drone technology with which you can converse on a social media. And the fourth is become like a roadmap for a large geographical world, and about our company Keshava, and later about a Q&A. So this is what a case study of a drone technology. And so what we have done in a Kolkata Development of Authority, like a call center process. And here it has been like a administrator of a community. See, for a smart city, and it is thought of a community in general. For community is managed by an administrator. And administrator is the person who takes the responsibility, and he also has the authority to assign a work and to manage the city. And that is his responsibility to sustainable development of a city. See, for that, he needs a data. In this is true data, transparency data. So where he'll get from a drone technology. So I'll give you examples like, see, usually in everywhere it could be happen. So if there is a heavy rainfall, so if there is a canal, it will be like a submerged. So how he knows? So to take a quick action, the data are very important. And recently, actually, in our hometown, a leopard entered to the village. But government and administrator has taken a lot of things to make change. But through help of a drone technology, through help of the data, so it is easy to identify and as well as to rescue the animal and as well as the people. So that the technology, in the sense, the drone sustainable data is very important. And this we have done in a call center process, and that helps for a planning for a long term and as well as to take a decision. See, we have more than 10,000 cities in the world, and these cities will become a large and urban form. For this, call center process is very important, and that is the development to think as a thought. And this helps for a sustainable development of a city. So hope you are all getting. So let's get in next. So here we are facing a problem of urban environmental community. See, like so many problems in a daily life we'll face, like waste and pollution. See, if the population grows, obviously the pollution will be grows, like a stagnant water, like a solid waste, garbages, and refuse from the water waste management. And so like a municipal waste, the people will put the construction delivers. So everything. So to take this action, the administrator wanted data for a zoning purpose. So for that, to take a quick action, the aerial data is required. If there is an electric accident. So what the reality happened, what the situation happened, to identify the problem, so that the data is very important to get a better, to make a better situation. If there is a canal blockage, so how the people will get to know? These are all like unavailability data. To make it as a develop availability data, the transparent data is required. And it is not been like today we are settled. So it is like a daily process. In a smart city, like daily the challenges will come, daily the things have been happening. To solve that, so drone data is very important. And next week we'll come on to the knowledge of the city. See, for this, like a road condition, about a layout, about a street, structural street, and about water assets, street light, and building, parks, everything. So in a city, if companies are going to build their own buildings, so while constructing, so many damages will be happening. So how the government will get to know? So with the help of the data. And next we'll move on with the infrastructure. So actually, so this is the city goals. So about the city goals and what the old infrastructure and what could be the next future infrastructure, and what is the condition of a water assets, what's the condition of a power utilities, and what is the condition of industrial like manufacturing. So, and also there is a planning for like a, so where could we install a solar panels, and where could we install like a wind energy solutions. For this, a transparent data required to make a sustainable development of a city. And if we come to the future plan and roadmap development, see, it has been like a continuous. So what we are talking of problems, these are all unavailable data. So to make a develop data, so call center process is very important. What we have done in a Kolkata. So that is what the thing, where is the problem? We'll get a call, and obviously we will make a drone flight. And so we will identify the things, what the happen. With the help of our RO software and with the help of associated software and hardware, and our operation teams will go and we will give the accurate data. And while seeing that data, obviously, the administrator or any manager, they could take a reaction and they can give a solution. So this is what I like call, fly, and take an action. So now there is a map preparation analysis. See, this is some examples what we have done. So here you could see this maps. So this is like a master plan preparation. Superimposition with existing proposed plan to help provide critical information to city planners. And this is, I'm talking like a use cases to emerge with the Newton sustainable offer development. So these are near real time maps that generated from a drone data. And here you could see the second image like a tree count for asserting green cover and decided on a future action. So here we could see the tree count, how many trees we have, and also we can get a plan to planting, seeding, and if there is like a trees, so what is the condition of a trees and what the water condition and all things. And if we come to the third, like a zoning analysis of a land. So for example, if there is a municipal, they have lots of plans. So they want to make a zoning and they want to analyze. Here it is a drawing you could see. And the third form is a study of planned and unplanned growth to prepare a master infrastructure plan. So always the city has to be developed to maintain a sustainable development. So the data are very important and that's required actually. And if we come to the next, construction status identification and a measurement. See here, if a building is constructing, so this month, this kind of work happened. What could be the next month? So while getting the data and what the thing are happening and about the building, beside the building. So what the status to check? So we want the aerial data. And here there is an important like a existing canal infrastructure. So what is the infrastructure of the canal and how to get, if there are any encroachment beside that, and what are the things are going to happen. So there we can come to know. And here you could see that encroachment identification. This is like endless use cases. So we have to do every time. So for maintaining a developed city, so drone data is very important. So next we'll move on with the waste identification. So this is the major largest problem we are facing. See, it could be a source of pollution. So you could see there. So beside the building, so there is a waste dump. And here you could see during like a canal, so the water has been blocked. And here it's the road frames been damaged. So it not only like a road damage, it is like an environmental damage. So construction delivery, solid waste accumulation, like a canal blockages. Due to this, so many diseases will come. So while giving this proper data, so the like waste management contracts can audit this, and if there is like a they could take a further actions. See, for example, for a garbage, it is having a huge problem. So they can take an action. So if there is a building like an apartment, so they could plan. So daily, like a garbage vehicles, they could come, and what are all the garbages are there? So you have to daily, you have to clean your home, clean your surrounding. They could give a messages to the people. So, and this impact actually it's very good. So like what is the waste of like a dry waste and a wet waste? You have to separate, and daily vehicle will come. So you have to through the where and all, you should not do that. So like that, the management or a government can take change to take a next step to maintain a developing thoughts. They should want a true transparency data. So here we are provided, and this happened in a Newton case. So hope you're all getting. So we'll move on with the next. So here it is a water bodies. Say actually this is also one of the thing. Here I would like to share a thought of two problems. So daily we are reducing our water bodies, and as well as we are not maintaining that water bodies. See here you could see. So there is a pond or lake. So what are the existing water bodies, and we could maintain a register of ponds. And also while near, we could take an action for encroachment people, and as well as if there is a buffering zone, we could plan. So during a flood or during a heavy rain, what kind of the better action we could take. So, and also here in this image, you could see the park has been designed. So with the help of the canals, if there is a park and all thing is that being like a smart city. And here you could see that near the canal, there are trees. So that is, we are maintaining our resources. This is the form. And also they could take a action for encroachment people. So this is supporting thoughts to sustainable development of a city. For that, data are required. So next we'll move on with the next slide. Say 1,000 plus specific insight on demand. So when you want. See here, in a first image, this is a government land. And here due to rain, so here some stagnant water is there. And also you could see the people are opened a shop and being like an encroachment. See, in a rainy season, mosquitoes and all, it's like a breathing area. While showing this data, the government could take an action, and it is a government area, so you should not do, and they could clean that area. And here it is a green port. So, but what the beside people they have done, they have dumped a construction material. So this is the actual truth that we are giving to the government. So they could, like a authoritative person, so they could take an action, and they could give a like a warning, or else like they could charge them. So this is a government property, you should not use this like this. And by showing this, they could do better. And here you can see that thermal solar inspection area. So here we could plan where should the solar plants panel could be built. And also it is a thermal foam, and the thermal camera has been associated for a security purpose. And in a fourth image, you could see here the canal has been broken. So here there is some renovative form. So if the government is not taking an action while seeing this, so it could be a huge cost. And to renovate this, it will take a much form. And this is what we have done in a Newton town for a sustainable development of a city. So here is the first, we are closing with the first idea. For a Q&A, so we could keep in the last of the session. So we'll move on with the next slide. See, this is an idea of sustainable finance with the monitoring outcomes by drone technology. See, here you could see like enabling financing of forestation by sale of carbon credits. See, actually, people want to build a green board, and it is a thing we have to think about rising our green power. It's just an idea. And also, the government has so many projects and so many schemes. Like people will use a carbon credits, but the government is not having a proper record. They are not able to return the loans and all things. But with the they could match the record, and they could analyze. So for example, so for a 50 acres, if any organization or else any person, they could take any loan or for a planting some other thing or else. But the government can check. So what the thing are happening through the help of drone data. And it is also help to collect the carbon credits. And also it is another idea. So the greenhouse planting is very important, especially in this generation. So for that also drone data will help. So this is based on a financing technology. And if we move on to the next idea, see factual reporting with the aerial data. See, always people want more and more, like more property, more thing, more lands and all. If any organization wants any loans, so, and nowadays it happens, a documentation, it is being a very big problem. While taking a record, and we could check aerial data, which is a proper thing for a mortgage and all things. We could analyze whether it is a proper or not. This is a transparent data, and this is helpful for a sustainable development thing. And this is a continuous process. And if we move on with the next form, see here you could see this is a major big problem what we are facing every day. See, 80% of river plastic steams from thousands river. So ocean cleanup project. So we are cleaning the ocean. So not only that, so first we have to think where the pollution is happening. So 80% of a plastic or 80% of river ocean is polluting from 1,000 of river. So first we have to stop polluting from the river. So we have to check where the problem is. So individually we can't do, or else people we can't do, but computer can do, technology can do. So we have to identify where the problem is associating, and we can identify who is a polluter, and government can take action to those. Like there is this wording is there like out of sight and out of mind. So actually it's very big thing. So ocean cleanup project, and it is a responsibility to take for every individual, because these are all assets. So we have to maintain and we have to care of that. And the proper data will help to sustainable development for ocean cleanup project. So we'll move on with the next. This is an idea. City Adapt, an AI powered by drone technology with which you can converse on a social media. See here, assume ARO is on a Twitter board. So if you tell like, see how much electric pole count are there in a Bangalore, the RO is telling, so there is a 20,000 electric poles are there in a Bangalore. And you could also say that how many tree count are there in a Tumkur. So RO is telling 100 trees are there. And what could be for a next 5 years? It could be for a 500. So it is a growth of a 5 or a 10% from a last year. So think if the software is giving the proper information, so how could be? And this is a thing here like a township called a sector 5. And anybody like can access, can check. So it is also an idea. So what we are giving. So if you want more, you want to go to website like isector5.com. And about Keshava, so we are a drone-based startup. Actually, the thought started in 2019, and in 2020 we spoke to customer, we launched it, and 2021 we have started as a commission, and we have started a call center process in Kolkata. And we are having a product called Aru. The software is a real understanding. So data-based software. And also we are looking for a partner, senior colleagues in industry across the world to solve real life problem. And here there is a last form. See, if the planet is divided, or else like if geographical is divided, so drone data can help to the forest, can help to the desert, mountains, and as well as for a factories, urban, rural, mining for a beach. So everywhere drone data can help for a real problems. So, and thank you for everyone, and special thanks to Ruchi. So if you want to connect, so you can connect through mail like amrita@kesava.com. So if you have any questions, you could.
Yes, if anyone has any questions, please do put it in the chat box.
So hope you all enjoyed.
Yes, ma'am. This presentation was very delightful to hear, and we got a lot to learn about your software and the detailed intricacies you have explained in detail in your slides was very fruitful to me personally, and I'm sure everyone had a good experience as well. We thank you for hosting your slide here, and hopefully we can connect with you later. Thank you.
Thank you, Satvik. Thank you so much. And thank you, everyone.
So moving on to all the delegates here. Next, we have Dr. Inam Danish Khan. Excuse me for my pronunciation. We have Dr. Inam Danish Khan. He's a associate professor at Army College of Medical Sciences, and today he's here to talk about drone-enabled logistics for emergency casualty response. So this is something we have already seen in the meet by other people, and we would be more than excited to see what Sir also has to tell us. Giving more insight into him, he has also written a concept paper on advanced aerial casualty mobility coupled with drone-enabled logistics for emergency response to boost operations. And giving more insight into him, he's passionate for academics, research, knowledge sharing, and adventure. And he has 16 years of professional experience. That is quite impressive in emergency healthcare, outreach healthcare, and global public health. And the list goes on, many such experiences. He also has a lot of experience in consulting, research, and publishing. And here, what I've seen is very interesting is he has adventure experience as well. 21-year experience in leading and instructing on rock climbing and mountaineering. Sir, I hope you have a lot to offer for us today, and please do take over. We are excited to listen to what you have to say.
Can you hear me? Am I audible?
Yes, sir, you're audible.
Okay, and I have logged in by 2 different devices, one for the video and the audio, and one for the slides. So can you just flash the slides also?
Which is your other account, sir?
See, it's ZAR, CZAR. CZAR,
Okay.
From that account, I want to flash the slides from a different video, from a different screen,
Okay.
and one screen will be for my own video and audio.
Okay. I've prompted you to start video in that account, and you can start sharing screen from there.
So I have to share my screen from here.
Yeah.
I don't think the screen is visible.
It is visible, sir. We can see a concept paper.
Okay. So I think it's not visible to me.
Yeah, I know, but it should be visible to you actually.
So for now, it's not the, okay, fine. Yeah, it's visible to me as well. So everything is all right. Shall I start?
Yes, sir, you can start. Everything visible and perfect.
Okay. Good afternoon, all of you. So I am Dr. Inam Danish Khan, as already introduced by the chair. And I would like to deliberate upon a concept paper. Not that I have got any actual experience in drones, but it's just a concept paper which can be applied in a real life scenario, as was what my predecessors have also been talking about. Right. I have nothing to declare, and let's start with this. So this scenario, what was there in the first slide, was actually a picture of the Hajj pilgrimage. And in 2016, I had a live experience working with the Hajj pilgrims in Saudi Arabia. And I would like to walk you through this experience. And I would like you all to engage with me in a thoughtful engagement, that in which all scenarios we can apply these drones and how we can improve upon the overall Hajj operations, especially the healthcare operations. So I'm a medical doctor. So I will be talking about a lot of things about the medicine and evacuation and patients. So for those of you who are not accustomed to the medical terminologies, I beg my pardon. But otherwise, I would just like to keep it as simple as possible. So the Hajj is an annual mass gathering of 2 to 4 million pilgrims from about 200 nations. Right? The duration is about 45 days, and this happens in a harsh desert climate of Saudi Arabia. Right? In this 45 days, there are critical 5 days in which all these pilgrims, they stay in minimal clothing, in tents, or sometimes they are just in the open, they're unsheltered. Right? The rituals in this Hajj pilgrimage are physically demanding, and there is a moving assemblage which is very, very difficult to control on its own, as well as even by the best form of surveillance. I will show you a lot of pictures also. So I understand that For those of you who are new to this, it will be difficult to understand, but I'll show you a lot of photos as well. Then there are surging troops, right? And there are congregations of more than 9 people per meter square, right? All of this, culminating into a food, water, housing, transportation, crowd control, communication, sanitation, and overall security, challenges. And these challenges are multifolds because all these pilgrims are not from the same countries. They're not from the same region. They have different cultures. They have different languages. It's completely heterogeneous, right? Different kind of education. So all these things and we are talking about 2 to 4 million pilgrims at one place in one city, right? So this is how the Hajj is designed. So what happens is that the main city here is Makkah, which is labeled as 1, and here there is a grand mosque. Now all these people will be here in this mosque, right? You can see that black structure inside is known as Kaaba, right? And after that, they will move from here on foot to a place known as Mina, right? And they will do some rituals here. Then they will move, this is number 2, right? Then they will move to another place, which is known as Mount Arafat, right? It is in the Arafat Valley. So this terrain is desert terrain, as well as a lot of mountains, right? So what I'm trying to highlight to you is that in case we are trying to use drones, then we have to avoid these mountains also, and there will be a lot of dead space. So all these things will be there. So I just want you to keep thinking aloud that what are the challenges and how we can develop a solution, because I want you all to be participating in this, right? Then from 3, they come back to a place known as Muzdalifa, and this is number 4. And here they will do the stoning ceremony, and then they will come again back to Mina. This is number 5, and then finally they will come to Mecca. So it's not just at one place. The entire assemblage is moving as well. So what happens? So what happens is that what are the challenges? And I'll talk about only the healthcare challenges, since I am a medical doctor and I have experience on this. So there is very high morbidity and mortality. So morbidity is that the number of diseased people will be very, very high, and mortality is the death. So a lot of people will die because we're talking about 2 to 4 million pilgrims. In addition, there is a risk of disasters, stampedes, polytrauma, and disease outbreaks, right? So a shorter form of what we had as a COVID pandemic, there can be an epidemic there in the Hajj itself because of so much of overcrowding and so many people moving around. Then there are challenges to global health security, and there have been outbreaks of many diseases in many different years, right? And it's a mass gathering healthcare system. So we don't have very well established hospitals and operation theaters, and emergency response systems are not there as much. Most of this is the people are staying in tents, and a lot of these hospital and healthcare systems are also in tents, right? So basically it is a mission operation scenario. So we call it, so every country will establish its own Hajj medical mission. Like the India, it developed its own Hajj medical mission that has been running every year for every year's Hajj pilgrimage, and this will cater to the Indian pilgrims, right? So we'll come back to the details later. And there are challenges of healthcare accessibility and utilization, and there are a lot of ethno-linguistic and socio-cultural barriers to this. So see this is that grand mosque, and you can see in this is that Kaaba, right? And you can see these crowds, right? And there is no space to stand or walk in this entire thing. Whatever the place is remaining, also that is also crowded. I will show you another picture here. You can see this is the kind of people who will be standing, and they're not wearing proper clothing also, and they're standing in sun. It's a desert climate, so they are very much prone to the heat effects of heat as well, right? Then you can see, so coming to the Indian Hajj medical mission. So it's an annual medical mission, and it caters to about 1 to 2 lakh Indian pilgrims every year. Approximately 150 doctors are deployed here, of which 50 are specialists, about 150 paramedics, and there are 75 or so ancillary personnel who are non-medical, but they support, right? Now, in 2016, there were 14 doctors in our team who were leading the entire contingent, right? And it was a limited resource, limited opportunity scenario. We didn't have anything to actually look after all these so many pilgrims. And we had to maintain a holistic health security with a strategic mission posture, right? So this is the kind of places which are there. Now, this is at Mount Arafat. So a lot of pilgrims are here, and in case something happens, there is no way they can run down, right? Something happens on this mountain, it's a mountainous terrain, it's a rocky terrain, so they will be stuck there itself, right? Okay, and now you can see this is the central Kaaba, and these people are circumambulating. So this is another place where there's a lot of chances of stampedes. So each and every place, like it be it Mount Arafat or be it this Kaaba, we had to establish a medical mission, right? We had to deploy personnel, we had to establish some kind of medical aid at all these places, right? And there's no place to stand or move about, right? So what we did was we targeted these 5-6 things. First was the mission preparedness. So it was a challenging mission, and we had to ensure how high operations throughput, because in such a scenario, obviously the kind of patients that will be coming will be overwhelming. Then we also had to ensure disaster health preparedness, and we had to conduct all the drills and standard operating procedures wherein had to be in place. Then we had to establish health intelligence about pre-existing chronic diseases. Like we now know after COVID, all of us know that people die more when they have got pre-existing comorbidities. So we had to establish this health intelligence. Then we had to establish this epidemic intelligence, right? For respiratory diseases. That time there was no COVID in 2016, but nowadays the Hajj is also having this challenge of COVID as well. Then we had to establish some real-time surveillance systems and also emergency response systems. So what we did was we established an echelon-based healthcare, right? And this was everywhere in all the, there are 2 cities involved. So both cities were covered and all these different points were also covered, right? So there were mobile medical task forces with which were catering to about 5,000 to 1 lakh pilgrims. There were static clinics, there were tent clinics, right? There was a mobile referral tent clinic. Then there were 3 secondary care hospitals, right? Where we could do some operations and we could admit the patients. And then we also had some referral and evacuation capabilities with the ambulance network, right? And we had to refer these patients to well-established tertiary care Saudi Arabian hospitals. So you can see this. Now this is the world's largest tent city. This is known as Mina, and this caters to that 4 million pilgrims will be staying in this tent city for about 5 days, right? See, this is the kind of road networks which are available in these 10 cities. So you can see that it's the road networks are also have to be very extensive, and even on these roads people are walking. So it's very difficult to move the ambulances or move anything because of all these crowds. That's why these are elevated and grade separated flyovers have been there, and this clover leaf formation has been made. Despite of all this, it is overwhelming, right? So the research that was conducted in this kind of scenario was having an ambidextrous and an outcome surveillance design targeted at health intelligence, the extent of morbidity, mortality. This morbidity is the disease and mortality is the death, right? The mission challenges and the opportunities and interventions that can be planned. So what we did was, so in this moving assemblage, in all these buildings that you can see in between these buildings, then we found spaces in restaurants or any kind of buildings to establish our camps or the medical tents or the hospitals, because there are no special places for all this, right? The total patients that we catered was about 4 lakhs, right? The number of pilgrims that went from India were about 1.5 lakhs, but because they're staying for 145 days, so the total number of patients catered were about 4 lakhs. The doctor-patient ratio was about 1 in 1,000 approximately, and the paramedic patient ratio was also about 1 in 1,000. In this kind of a setup, there was an outbreak of food poisoning which affected 90 pilgrims. There were many road traffic accidents, and there were a few fire incidents as well, right? So if you see the healthcare intelligence, a large number of these pilgrims are in the 70 to 100 years of age, which have got limited mobility. They cannot run, they cannot walk fast, so they need a lot of help, right? The data, I have compiled the data of these 5 years, so this can be seen well, so that you can see that the number of pilgrims are, and the number of pilgrims with chronic diseases were also quite a lot, right? If you see the incident reporting systems, then we see that there are a lot of other incidents as well as traffic accidents that were happening, such as the stampedes and fire accidents can also be there, right? Now, if you see the patient footfall, which comes to these clinics, so the static clinics, they catered for about 3,75,000 patients, right? The tent clinics, about 5,000 patients, the mobile medical task forces, about 13,000 patients, and the rest were to the hospitals, right? Now, the total patients in healthcare, we have got primary care, secondary care, tertiary care, quaternary care, right? So these are the echelon healthcares. The first echelon was the primary care. Primary care is the basic tent kind of a setup, which is established everywhere, wherever the pilgrims are there. So that was the main place because it is the pre-hospital care, right? So this is the mainstay of care because that is the emergency care, and emergency first is to be provided at this level only. So total patients catered by primary care, right, was 3,92,000, and most of these patients who came had pre-existing diabetes, hypertension, heart diseases, as well as respiratory diseases. In secondary care, about 1,000 patients were there, and we had 3 Indian hospitals of 40, 30, and 10 beds, and we catered to about these 1,000 patients, right? And this, you can see that about 63% patient had to be admitted, of which about 58% were males and 63% were females. So females have got more conditions, more problems compared to males, right? And 55% patients were elderly, more than 70 years of age. Right, and we catered for crush injuries, dislocations, fractures, right? Female patients used to come with abnormal uterine bleeding. So they just started bleeding on their own, and it was very difficult to control this kind of bleeding. About 15-16% patients had mental health issues, which is another big problem, because once the patients are psychotic or depressed or having anxiety or phobia, and they have got a lot of stress, then they also don't behave in a way which is required for that kind of a scenario, right? Some of them will have obsessive compulsive disorders as well, right? Then every patient is having a lot of stress because of heat, because of dehydration, because of no food, because of walking for a long distance, because of all these issues are there. They are exerted, right? Then there is dehydration, and most of them are in old age, and they have got multiple problems, right? So total of more than 2,000 bed days were there of these patients, and the bed occupancy was close to 80%, which was also very, very high, right? The bed occupancy should not be very high because it affects hospital operations, right? And every patient was admitted for about 3.5 days for one episode, right? And overall, it delayed the definitive care. So this is the data, and you can see that a lot of diarrhea was there, a lot of heart attacks were there, a lot of respiratory problems were there, a lot of trauma was there, fractures were there. So these were the most patients there, and all of them needed some kind of help. Right now, if you see, respiratory infections were about 53%. That's the highest, and every patient was breathless, and there was a lot of overcrowding. So had COVID been there, it would have been a disaster, right? And there were a lot of patients with a lot of orthopedic problems like fractures or strains or sprains, and they were not able to walk. So total patients in tertiary care, which were sent to the Saudi Arabian hospitals, were only about 500, and most of them, 20% had heart attacks or some other respiratory diseases, right? And some of them had to be amputated, right? And because they had a lot of fractures. And so if you see the overall load here, so it was about 140,000 patients. And this load has reduced over the years because Saudi Arabia has already started using drones for surveillance systems, but not for actual patient care as of now. So you can see here in this slide also that there was Minna stampede and crane collapse in the year 2015. Because of all these kind of accidents, also a lot of people died, right? So the all-cause mortality, that means that what I'm talking to is that the cause of death by all the causes combined is about 12 pilgrims per 10,000. So that's also very, very high, because they are supposedly not in the hospital. They're not terminally ill, but they're still dying there, right? And you can see that this is the kind of crowds. So in case of any casualty, any fracture happening, it is very, very difficult to evacuate the patient, or even it is more difficult to reach the patient. So how will the mobilization team reach that patient who is not visible? Because that patient will be sitting, or the patient will be lying down, and there's a chance that the patient can get crushed by this kind of moving assemblage, right? Now you can see this kind of scenario. If one patient gets heart attack, there is no way the ambulance can reach, or the doctors can reach, or any kind of help can reach. That is where drones are required, because at least the drones can identify that this is the place. Drone can send a GPS signal that this is the place where the patient is there, and the drone can also start early warning systems that other pilgrims can also start helping, because they are also not aware that the other patient is dying. So overall, the mission throughput was overwhelmed. There were a lot of operational stringencies, like what I already elaborated, and there was a question of interoperability, right? How to coordinate all the teams together. So that was a big thing. Then more than 90% healthcare personnel, they themselves were suffering from respiratory infections. So because of that, there was another challenge, because they were also sick. So they were also not available all the time. And there was a lot of physical, mental, and compassion fatigue in the pilgrims as well as in the healthcare teams. So now you can see what can be done, because this is a solution-oriented scenario, but though it is a concept paper, so we can use lot of tethered drones. Now these tethered drones, the advantage is that they can be static and they can be deployed at one place, and there can be a monitoring station also. But the only thing in this kind of tethered drones is that the vehicle which is tethering this drone has to be there in place prior to the event. We cannot move this vehicle during the event, right? Similarly, we can have tethered blimps or we can have helikites. These are very good. But the only problem is that they have to be static. They have to be there for all the time. They cannot be moved because of this kind of crowd. Right. So what can be done with these drones? So we can enhance the surveillance. This already is being done. So Saudi Arabia, since past 8 years or so, has been using drones for active surveillance, right? That surveillance is being done, but the surveillance is not based on healthcare parameters. This is only for the crowd monitoring as of now. So what can be done is that we can be extended to the active patient identification. Then these drones can be used for delivery of emergency medicines at the site, or they can be used for delivery of medical equipment at the site, or it can also enable telemedicine, right? And overall, it can boost healthcare in difficult weather and terrain. So I'll just elaborate how we can do this. So you can see this. Now, this is one of the helikites, and this helikite is already established and it is monitoring one particular area, right? So this one particular area is targeted for this helikite. Similarly, that there is one more helikite. So this is how it can be used, right? Now, surveillance can be done for active patient identification. Secondly, if there is overcrowding, that can be seen. Now, drone can also establish a warning system. So like it can have lighting systems that, okay, which can pin laser-based lighting system, which can pinpoint to the patient or the area where intervention is required. Then we can have drone guided search movement and direction. So the moving people can also be guided by this drone-based warning system that don't move in this direction. There's a lot of search there, right? But the caveat is also there with all these drone-based systems that we need expert drone pilots who know what is going on in the Hajj pilgrimage, who know what are the problems that can be there. Then there can be drone accidents, like the drone can fall or the drone can crash. So in that case, we need to have a secondary drone. We need to have a backup drone. And we also need to educate the patients that this kind of drone will be doing a surveillance, because these patients can have drone psychosis. Like they see a drone which is monitoring them and they will go psychotic. So these are the real life problems which is there with humans, right? Then the second thing is drone delivery of emergency medicines. So what can be done? We can deliver adrenaline, painkillers, anti-asthmatics. But again, the caveats are we need expert medical personnel. We need support logistics. But like if the adrenaline is there, we need a syringe also to administer it, right? So it's not just the adrenaline. We need a lot of other things which have to be catered. Then we need to do some kind of crowd education so that they are able to support the patients, because a lot of them, they don't understand what the patient is going through. So they just run away, or they will just do no kind of support is there. They will not move so that the access to the patient can be secured. Then the third thing is that we can establish drone delivery of medical equipment like automated external defibrillator. So suppose a patient has got a heart attack or a patient is having a failing heart. So in that case, this automated external defibrillator will be handy, right? But now we need medical doctors at site who will use this AED. Not everyone can use it. So some paramedics who are trained enough, they can use it. Otherwise, we need doctors at site. Now, how do we position those doctors? Because we just had about few doctors, 150 doctors. So it is not possible to place one doctor at each and every site, right? And the patients, they have got a different language, like because they're from so many countries and they're all mixed up. So language barriers are also there. Similarly, we can deliver splints, we can deliver bandages to stop bleeding, and we can deliver some kind of airway management devices, like we can deliver the pumps which are having anti-asthmatics. So all these things can be done with the drones. Then what we can do is that we can do drone-enabled telemedicine. Now, this is very, very important, because a drone can monitor the patient. Even if the doctor is not able to reach there, the doctor can sit at one monitoring station and can guide the patient by himself, or a paramedic who is there with the patient to what is to be done. This is one very, very big thing, because if we have got an army of drones everywhere, then these drones can be deployed to look for multiple functions of the patient and monitor the patient there itself, right? Or just take the photo of the patient and send it real time, so that we know that, okay, the patient is how breathless the patient is. A doctor can, sitting at a monitoring station, can monitor the respiratory rate of the patient just by the drone footage. So all these things can also be helpful, right? But we need experts at both ends, and there are a lot of dead space limitations because of these mountains. So because of the mountainous terrain, there are a lot of dead space limitations, right? So you can see these are the tethered drones, and all these drones, they have got different kind of capacity. The payload capacity is different, the altitude range is different, and the kind of anchoring that is required, that can also be different. And this can be enabled in the Hajj infrastructure and the Hajj geography, right? So now you can see these are this looks very good on paper, right, on the concept, but stationing a vehicle or all those mountainous places is not easy. That's very, very difficult, right? So, but still, if we are thinking aloud right now, maybe in future we are able to position all this, right? And so far, what has been done, right? So far, what has been done in Hajj is that these drones are being used for monitoring, observation, and coordination. They are used for surveillance, but crowd surveillance, not medical surveillance as of now. They're used for lighting and everything. They're used for 5G coverage and emergency communications and maybe disaster relief, but on ground, medical relief is far and it's just far and few. So that is where we need to intervene, that we should enable this drone surveillance and drone operations to boost the medical capacity, right? So the recommendations what I have for this kind of scenarios, not only for Hajj, we in India, we have got Kumbh Mela, which is bigger than Hajj, right? We have got so many events which are much, much bigger than Hajj. At least 4-5 events are there in India, but which are not yearly. They are every few years, but they are bigger than Hajj. So here, drones can boost preparedness. Yes, we need more doctors, we need more paramedics, more ambulances, more medical equipments, but we need more drones as well. Secondly, the clientele has to be young, healthy, knowledgeable, and disciplined. They should be attuned to the presence of drones, and they should know how to use drones for their own benefit and for people's benefit. Then we need to boost the health systems with drone adaptation, which is again one big area which needs improvement, right? Apart from that, we need a lot of risk modeling by static modeling and dynamic modeling. We need artificial neural networks, right? It is not just a one thing. We need to blend technology as with healthcare, which is in itself is a big thing, right? And we need a lot of telemedicine and decision support systems, right? So without the drones, I have published about 5 papers in this Hajj medical systems. This was the first paper. So, and this has been widely cited. This is the second paper. This paper is basically on the administrative aspects of how have we built up all these capacities, right? Then this is the third paper on operations throughput, because we have a lot of patients in one point of time. So we are not able to cater to them, all of them. So operations throughput and the concept of golden hour is questionable in this kind of health system, which is in tents, right? So this is to boost, how do we boost the operations throughput in this kind of a mass gathering medicine scenario. Then this is the fourth paper on emergency response to heat illness, right? Because a lot of people came with dehydration, and they came as unconscious, and they were just having the effects of heat, right? And this is another paper on the kind of obstetric things, because a lot of these women, they go there and they deliver also during the Hajj. And just imagine, you can just imagine, I will leave this to your imagination, that a lot of people are dying, a lot of people are having so many problems, and there are women, pregnant females, who are delivering babies during Hajj, and they have to be taken care of. Both the mother as well as the babies have to be taken care of. And this is then, and a lot of abortions, they keep happening, right? So all these things, like in 1 year, there were 20 vaginal deliveries, right? And there were 2 cesarean sections and 32 abortions. Just imagine that all these things happening in this kind of scenario, because people come from different countries. They have no concept of the fact that they should not be delivering during Hajj. Rather, they think that they should deliver during Hajj because it is considered auspicious. So people coming from third world countries, that includes India as well, and other countries, they do this as well. So we have to cater for these kind of patients as well, right? So these are some of my references which I've worked through this. And and there's some ref packs which are like, this paper has been presented, the similar paper without drones, in the WHO conference on mass gathering medicine in Hyderabad. And these papers have been widely cited in Times of India as well as other newspapers, right? And both the Indian guidelines and the Saudi Arabian guidelines, they have been modified after the publication of these papers, and they have incorporated all these scenarios, because there are few papers on Hajj systems earlier than this 2016 paper. So with that, I finish. And I will leave the forum open for any questions, additions, or comments.
Thank you, Dr. Inam. This was really impressive and really thought-provoking. We have a lot of drone technology partners in this conference as well. I'm sure they're going to borrow a lot of your ideas, and probably we can find opportunities of utilizing all of them, because what happens with drone technology companies is we are in search for use cases, like great use cases. So when we have great use cases being explained like this, I guess it gives us a momentum to start working on these ideas and start looking at that as a potential business case as well. What do you think, everyone? Can I have some questions, comments, anything in the chat, or if anyone would like to talk about it?
Yes, I would like to say it was very overwhelming for me listening to so much detail about stuff that I've never heard of that are incorporated with drones and medical care. Yeah, I think I learned a lot during this slide. Thank you, sir.
Dr. Inam, can you just stop sharing the screen?
Yeah, sure. Okay, thank you very much. Thank you, Ruchi, for this opportunity, and I yield back.
Dr. Inam, I guess you will be here for a while, so we can ask some more questions to you. But then
Yes.
I would like to ask you, since you have also worked with military forces, and you've also probably observed how they use drones. You also spoke about drone psychosis somewhere, wherein yeah, people are afraid of drones. Where do you think? I mean, how do you neutralize this this activity wherein we can make drones appear friendly, use them in use cases like yours, and also make the most of it?
Basically, it's about patient education, I would say, because what we have been lacking is about education and awareness. Like these days in the school education, they should be taught about drones and the function of drones. Basics, like just the concept building, not the technology, but the concepts at how do we help people with the drones. So once a child is growing up seeing the concept of drones, then they will be used to it. Like a lot of people have got aircraft psychosis, right? But once they start flying, there is no psychosis. So similarly with drones also, this drone psychosis is just, it's not something which is out of the box. It will happen. It is bound to happen if to someone who has never seen drones. But once people are used to this kind of a surveillance system and a network, then I think it will be very, very okay with everyone.
So we have a couple of questions coming in. What do you think about drone ambulance in India or in the rest of the world? Where do you think this happening in terms of how soon can it be, or how difficult can it be?
Okay, this is something which I have personally worked on since I'm a mountaineer as well. So I have also worked on the casualty evacuation from difficult terrains like mountains, and I've got a lot of experience in that as well. Now, what happens is that the payload capacity of drones is not that high, because to lift a casualty of, let's say, 60 kgs, the payload capacity should be at least 500 kgs. So because of the payload limitations, drones, it will take some more time. It's just a matter of time. So like, we need leapfrogging. The technology needs to leapfrog. Once we need to have bigger, more robust drones, right? So first is the payload capacity. They should be having at least 500 kgs payload capacity, because once you're lifting a patient, then the G forces are also acting. So it is not so that it's just a 60 kg patient, it will be about 600 kg patient. So payload capacity has to be very, very high, number one. Even the helicopters which come for this casualty evacuation from mountains, they find it difficult to lift a patient. It's not easy, right? Because of the dead space limitations, because of communication limitations, lots of things are there, and because of the rarity of air, because the air density is less. So all these things are there for casualty evacuation. This is one. Second thing which I would say is that the drone range has to be very, very high, because it's supposed to be, it may be possible that the hospital is, let's say, a few kilometers away. So we need the flying range, which should be very, very high. And then third thing is the communication with the drone, because a lot of times drone can get out of communication. So it will be, I think it will be at least, it will take 2-3 years where we will have a dedicated drone ambulance, which will be successful. And initially we should be prepared for some kind of accidents also, like the casualty falling from the drone. That is also possible, or the drone itself falling. So we need to work on all these things. It's not going to be that easy. And we need to do a lot of practice with that kind of payload, with dead payload, like not live patients. And then once we build up that kind of capacity, and it in terms of also in terms of the flight modes and the landing and the lifting, then maybe we'll be able to see it in real time.
That's absolutely true. Thank you so much for sharing your insights with us. We have a very similar question in the chat, so I wouldn't repeat that question. And we also have upcoming presentations on advanced aerial mobility, which would explain about the flying cars and the flying taxis and the flying ambulances much better. So thank you very much, Dr. Inam, for coming to the conference. He will be here on the conference, so you all can chat with him as well. And I hope you all allow people to connect with you on LinkedIn and chat with you, so that you can get in touch with him and onboard him as your advisor. I guess he'll be very happy to do that.
Yeah, definitely. I would be there too. I'll be available. And thank you so much, Ruchi, for everything.
Thank you.
Yeah, thanks.
Satvik, you can introduce the next speaker.
Yeah, sure. Yeah. So we all had a great experience with Dr. Inam telling about his advancements. Now moving on, we have something very interesting coming up from Mr. Wasaf Akhtar. He's going to explain about advanced air mobility. This is very interesting because could you ever think there's a taxi that's flying in the air like the ones from Harry Potter, if I have to quote here? Yeah, that this seems very interesting to me. And yeah, personally, people who have been in Bangalore know how hard it's to go from the airport to the city. It takes like an hour or two. And the concept of a flying car or a air mobility system that is unmanned is extremely interesting to me. And we'll see what Mr. Wasaf has to say. Wasaf, sir, it's all yours.
Hi guys.
Yes, sir,
Guys,
you're
can you hear me?
unmuted now.
Can you guys hear me?
Yeah, we can hear you.
Perfect. So let me start sharing my screen. Can you see my screen now?
Yeah, and I would also like to add Wasaf sir's company is from Cookie Jar. He's a CTO at Cookie Jar, and he's from Sweden as well.
Can you guys see my screen now? Can I confirm that?
Yes, we can see your screen. Thank you.
Perfect. So hello everyone. Good afternoon. My name is Wasaf Akhtar, the Chief Technology Officer for Cookie Jar based out of Sweden. First of all, I would like to thank Dr. Ruchi and Kerabotics team for providing me a platform to speak on this very topic of advanced air mobility, which was coined by Morgan Stanley as a $1.3 trillion industry. Today I'll be presenting to you all a topic on the infrastructure requirements for advanced air mobility. So let me take you back to at least a decade and century ago to understand how these technologies came into existence and what were the underlying infrastructure that was required to support these technologies. We had rail lines, roads, electric lines to support the cars and railways, right? We had power stations, transmission lines, and transformers to glow the electric bulb. We had radars, VOR, runways, and ILS systems to support the aircrafts to fly safely. And we had ISPs, the internet service providers and servers, to help different mobile technologies integrate with each other. So now in terms of our transportation system like advanced air mobility, we are moving from an era of 2D transportation system to a 3D transportation system of moving cargoes and passengers inside cities in a matter of minutes instead of hours. And that is a term that we coin it as advanced air mobility. Well, a new industry is on the revolution of, a new industry is on the cusp of revolutionizing urban mobility. And the race is on in developing the integrated transportation system of moving cargoes and passengers from the ground to the skies. What was once just a fanciful concepts in cartoons like Jetsons is now becoming a reality. With the advent of faster computation cycle, cheaper electronics, and lightweight materials, it has become feasible for companies to build these new beautiful electric machines. I was in Bangalore working in Hindustan Aeronautics Limited, and I was always traveling to and fro around 15 to 20 kilometers from one point of the Bangalore to another. And I always used to ponder how are these drones and air taxis going to be integrated in our day-to-day lives. What I found out was that it is very difficult to orchestrate the coordination and management of these new technologies in cities and in urban environments. Now you have these beautiful vehicles, the electric flying taxis coming out in the next 2 years. We have eHang, Lilium, Cora, and Volocopter. And cities in different parts of the globe are getting ready. You have Joby Aviation, for example, from the United States of America, which is an eVTOL aircraft company, looking at the prime markets to deploy their systems in Japan and South Korea, similar to Volocopter in Singapore and eVer Mobility, the Brazilian eVTOL aircraft company, which have looked as UK and US as their prime markets to deploy their systems. And there are more than 200 aircraft developers that are getting ready, and dozens of them are going to get type certified by their respective regulatory authorities like the FAA and the EASA in the next 2 years. So what is the problem now? How do you deploy these technologies in cities? It's a challenging situation, to be honest, because we are creating something out of the blue. We are creating this industry out of scratch, right? And the problem is that the cities and transportation systems in cities are having a legacy system that is just able to support the current mobility systems, but they are not geared towards supporting the emerging core technologies like drones and air taxis. So how do we prepare the cities and municipalities in adopting these new technologies at mass, which is beneficial for the operators to commercialize in a very profitable manner? So what we do at Cookie Jar is build these portable vertiports, which is a simple, scalable, and modular solution, providing a landing platform for drones and air taxis, right? So our basic mantra at Cookie Jar is to prepare the airspace and the ground infrastructure when the aircrafts are coming out in the next 2 years. And we see that most of the cities in different mega cities are not well equipped with the infrastructure that we are talking about here, like the vertiport systems that come alongside different technologies that we need. For example, Dr. Inam had mentioned you need to have communication ranges. For that, you need CNS nodes to communicate with the drones for different ranges. You need to have the UTM systems to oversee the airspace. You need to have electric charging stations to charge these drones and air taxis. And you need to have different kinds of systems. So these systems are not existing right now. So this is what we do at Cookie Jar. So this is what we are doing in Sweden right now. The vision is to create a large network of vertiports in municipalities and cities. This is what we are doing in Sweden, in a small town called as Malardin, where we are helping the municipalities to educate them and empower them and allow them to see the value that these technologies bring to the citizens. So they have been quite proactive with us in helping them understand how do we place these vertiports in their cities, and how do you interconnect these vertiports from one part of the municipality to another in different cities? How do you define those air corridors? So this is what we have been doing in Sweden so far. And our strategy is more like bus stop strategy. We do not believe in building a vertiport with 30 landing locations and takeoff sites in one site. What we believe is to have 30 vertiports in 30 different locations, more like a bus stop strategy. So this is one of the survey that was done by the European Union Commission, that Europe will need one vertiport and drone landing site per 3,000 urban residents by 2036. And what about the regulations? And this is quite interesting in being in drone industry, all of us now. So everything is aligned from getting type certification of the aircraft to standardizing the UTM systems in the airspace to standardizing the vertiports. So it's an interesting thing for us because we started last year and the FAA and the HIASAs have streamlined the specifications and the standardization of the vertiports. So the regulations are going to be ready by 2024. And moreover, there are trilateral agreements signed between the FAA, EASA, and the Chinese Civil Aviation Authority to start a new era of cooperation and ensuring that they have high safety standards and all are on the same page in terms of communicating the aviation language that drones and air taxis possess. And this is a community in Sweden. So we are an air mobility ecosystem of vertiport operators, the USpace service providers, the drone operators, and IBG. So what we do in IBG is a sister company of Cookie Jar Vertiports. So what we do is we provide urban planners and the airspace planners a blueprint in orchestrating how do you coordinate this airspace for different aircraft movements, for different volumes of aircraft, and for differing levels of services for municipalities and cities. How do you integrate these systems in an urban environment without posing any danger or hazard to the cities? How do you integrate these systems in an urban environment? Now, these are some of the challenging questions that we need to be answering first in order to deploy these systems. And we need to start to think that when these vehicles are type certified by their respective organizations in the next 2 years, we do not need to wait until that time to start building the infrastructure. We need to roll up our sleeves and start building the infrastructure right now, have those deep dialogues with cities and states and the central government, and the value these technologies bring to the citizens in those respective states and cities. Now, this is how you think the cities look like, the mega city look like in 2019. This was me in Bangalore taking a helicopter ride in 2019, and I was contemplating the burden the current transportation system is facing. And this is our time now. We need to start initiating dialogues with cities in building the infrastructure and educating them and empowering the state, central, and the local governments about the value these new technologies bring. So with that, I would like to conclude this presentation, a short and sweet presentation. I wouldn't want to keep you guys bored. So feel free to hit me up with any questions that you guys may have, or you can email me at whatsapp@cookiejar.com. And I would like to end this presentation by saying, let's grow the world by shrinking it. And I would also like to share a small presentation video that we have. Can you guys see this?
Yeah, we can see it.
Are you able to hear it?
No.
Now?
No.
Oops.
Maybe you need to go up on the top and
Let me
see the
check.
computer sound. Share computer sound. That's on the top.
Can you hear now?
No, we can't.
Are you able to hear it now?
No.
Oops. Let me do one thing. I'll just share the link on the
Yeah, that would be great.
Can you see
on the chat, and
the checkbox which
see that
says
there seems to
share
be some
computer
technical
sound is
problem.
on? There would be a share computer sound checkbox there upstairs, up on the strip. Let's try that.
All right. Let me check. Now?
Yeah, I think I can hear something now. You can increase the volume actually.
Yep, it's increased. Not know what seems to be the problem. I have shared the link on the chat box. Maybe you can see it over there.
Yeah. Actually, I had a question on this as well.
Sure.
Yeah. So, would something like this be possible in our city, like in India, like where it's so crowded and wires all around the city and this, and would it be affordable to our citizens in a third world country like ours?
We have done the survey in Asia, and we have come to a conclusion that Bangalore has got the most number of landing pads and the helipads in Asia. We were not aware of this, and now I'm telling you guys. So it is possible to create this ecosystem in Bangalore and connect the different parts of Bangalore so that people can move faster than ever before. So Bangalore has got around 98 helipads, which can be reconfigured to support these new emerging advanced air mobility vehicles. It is inexpensive. What we do at Cookiejar, like I said, we do not believe in creating expensive vertiports. We believe in creating inexpensive, modular, and scalable vertiports to support the landings of these drones and air taxis.
Thank you so much for your answer.
Welcome. So I'll be just sharing the video link on the chat box. You guys can have. Apologies for the technical difficulties here. So once again, thank you, Ruchi and Carerobotics team, for allowing me to present here. And I look forward to answering any questions that you guys may have. Or feel free to send me an email, which I had shared earlier. Thank you very much.
Thanks, Vasaf. So there are questions. Are these vertiports available in different sizes, costs, and you said modular, right? So can you explain that modular part a bit more?
Sure, yeah. So these vertiports are available in different sizes and costs based on, we design the vertiports on the design requirements of these eVTOL aircrafts that are out there. So you have 18 cross 18 square meter, be able to support the e-hang. You had 24 square meter vertiport supporting volocopter. So yes, they are available in different sizes, and the cost of it depends on the size that the eVTOL footprint comes out with. So when I talk about scalable, these vertiports come in modules, right? So suppose there is a requirement of increasing the vertiport size from 18 square meter to 24 square meter or 32 square meter or 50 square meter for the largest eVTOL out there. We can do it because it is printed from the factories, the landing pads. We have patents on the landing pad design of the dynamic landing system that we have incorporated in our landing system. And yes, they are modular and scalable from varied ranges and sizes of different eVTOLs in the market right now.
Okay, so are your drones powered by electric or hydrogen? I was confused actually.
Sweden, we are targeting towards a hydrogen economy by 2030. Right now, the standardization and regulations for hydrogens are not out. What we are catering to the requirements now is what is being asked by the industry is to support the installments of electric charging stations on the vertiports right now. But we are moving towards hydrogen economy in Sweden because billions of dollars have been invested by the Swedish government into deploying hydrogen powered stations to support these electric cars in and around Sweden, especially in the north.
Okay, interesting.
So Vasav, it seems there is a your video needs a password.
Okay, let me share it. It should be. Yeah, I apologize. There's it is password protected. So let me just share it with you guys here, and you can check the video. Yeah.
Vasav, is there a specific reason why you started off in Sweden?
Our prime markets are now in Sweden, Dubai, and Monaco. So what we are trying to achieve is to test the eVTOL aircrafts in different environments. You have on one side cold environment like Sweden, right, and then you have a hot Habibi environment like Dubai, where you can test the eVTOLs in different temperature conditions. So these are going to be our pilot test sites until 2024. And Monaco will be our next prime location, wherein all billionaires are using cars now, and they don't want to go utilize cars anymore. They want to travel by air rather than, it's a luxury factor for them. So these are our prime markets. This is the reason why we are doing it in Sweden and Dubai at this point of time.
And do you also see a difference in the way people perceive flying taxis or flying cars in these three countries?
Yeah, it's quite challenging that you brought up this question because it's a very important question that needs to be answered. Public acceptance is very important, and this is where we are facing a dilemma in understanding, will the public accept this technology? Well, we do not know. We do not know when some people in Bangalore used to say, okay, Uber, Ola, who is going to use it? We are going to use a normal taxi. But the perception changes as and when time progresses, and we prove people that it is a safe technology to incorporate in cities, and it will increase the quality of your life by spending more time with your family and doing more things that you have to, what you love to do, and the freedom to enjoy more time. So yeah, as and when we progress, public perception is very important for us, because at the end of the day, the consumer is our king, and we need to ensure and tell them that, look, this is a safe technology, and we will ensure that the safety standards are high, and you will have to use this technology for the betterment of your life.
And do you think the safety standards are high so far, or we need to do more homework?
Well, the industry is having a safety standard of 1 divided by 10 to the power minus 9, which means that you can have one crash for up to 10 to the power 9 flights, right? That's a very high safety standard. And it also comes with the triple redundancy of safety systems in eVTOLs, because NASA has been engaged heavily in researching the technology for safety management system, especially in deploying the systems. But I do believe that in order for this to be a reality, we need to ensure that safety is paramount, and we are working very hard in achieving that by looking into something like a triple redundant system in an aircraft, where if one rotor fails, the other rotors take over. If there is any imbalance in thrust propulsion of these aircrafts, the pilot has to land. The envelope of the pilot has to agree, the envelope of the aircraft has to agree to onboard systems to allow the pilot to land in a safe location. And that is why we at Kukijar are putting a bet that having more locations will allow the industry to meet better safety standards than having just one location with 30 vertiports and takeoff sites. So our goal is very simple. We would like to have hundreds of sites in a city rather than just having 1 or 2 sites.
And do you really think investors are ready for this yet, or they still need more data, more evidence, more convincing?
Well, almost $10 billion have been invested into the industry in developing the flying aircraft alone. And we have spoken to investors at Kukijar and telling them, look, the industry is at a point wherein they know how to fly, but they do not know where to land. And this is why we have our systems in place to help these guys land in places where we build our towers. So it's like you are providing a shovel to the miners, right? The miners need shovel to dig the gold mines. And this is what we provide to the eVTOL aircraft developers and cities. They need these vertiports to land. And also understand the airspace requirement around those vertiports. It's going to be challenging. We have been talking to all the stakeholders in Dubai and Sweden now, and ensuring that they have the oversight of the airspace, and also ensure that they have an enforcement authority over those airspace on those vertiports. So these are some of the questions that we are juggling with the stakeholders right now. Who is going to take what roles and responsibilities? So yeah.
Thank you very much, Vasa, for coming to the conference. I really hope that we continue working together, building some more use cases, and explaining to the world how this is all done. Thank you.
It's my pleasure, Dr. Ruchi. Thank you. Thank you very much. Thank you, guys. Thank you, everyone.
Thank you.
Bye-bye.
Bye. So we will have a 5-minute short buffer here. You all can take a break, stretch, bend, do whatever. We will be back at 4:30. Meanwhile, for the people who are still here, I want to open up a point of discussion. Where do you think air ambulances are in the timeline of the future? In the next 2 years, 4 years, 10 years? As for what you have seen in the conference so far, the presentations that have been shown to you, where do you think we are so far? Anyone can unmute and talk. Just raise a hand so we can unmute you.
Yeah, I would like to answer actually.
Oh, you want to answer that? Great.
Yeah. So personally, I think we are not very far away from having an air ambulance. Maybe it might take a bit of time, like I would say around 6 years, but 5 to 6 years. Because recently, even when I visited IASC recently, and they had a competition they had a competition that was given out to everyone. We have to design an air ambulance and submit it to them. Just a concept of it, not the actual air ambulance, but with all the technicalities, design papers. So I see there's a lot of interest in building an air ambulance with various institutions across this country. So I think the goal is there, but there must be more practical application work and more research needs to be done in this. But I don't think it's very far away though. Yeah, that's about it.
Shobha ma'am, you wanted to talk about it?
Can you hear me, doctor? But I can't hear you.
Yes, I can hear you. Sorry.
Okay. I feel that, as Satvik said, that 5 to 6 years, I think air taxis and the ambulance will take this much time, and not more than that, because I feel that defense is already using the payload capacity of drones, this much capacity they are using. So I think it's just a time that we can use it in the civilian thing also. So 5 to 6 years, 5 years, I think that is the time. And
Nice.
I'm very much interested in this field. So let me connect with Dr. Inam.
Sure.
I want to connect with him.
Vasaf?
Yeah, hi, Dr. Ruchi. I think it's going to take another 3 to 4 years to see air ambulances in cities. So like I said, our topic of infrastructure is quite crucial. If there is a heart attack patient in a place like downtown Dubai, where will he go? He needs to go to our nearest landing pad, and that landing pad must be equipped with necessary infrastructure for these vehicles to land. And you need to ensure that the airspace is also enforced and overseen by the respective regulators. So it's all about the technology is there, the standards are there, the regulations are there. I think it's all about now who is going to play that role and responsibility of, like I said, overseeing the airspace, doing their respective stakeholder duties in ensuring that these vehicles come and land safely there. So it's all about, getting all the stakeholders together under one single umbrella and having this discussion. How do we deploy an air ambulance in a city like Bangalore? In a place like Marthahalli, for example, where do we build those landing pads? How do we connect that landing pad in Marthahalli to a nearest hospital? How do you ensure the prioritization of the airspace needs to go towards the air ambulances services? I think it's not a matter of technology or standardization, but I think it's a matter of only regulations, and it's only regulations that is keeping us away from utilizing the application of these technologies.
You're right.
Thank you.
Vivek sir?
Yeah, I think if the industrialist supports now, it will be around 4 to 5 years. We will see air ambulance for civilians also. Only industrialist has to support it. Already the player, I think they have laid down the plans and everything. It's my point of view. Only the support is required for this.
Great. Maybe I'll just do a very quick poll over here. Meanwhile, if you have to carry your family in a flying car, would you be doing it? Yes, no. You can use your reactions. Yes, no. Something like that. Great. So I have a very motivated conference here. Awesome. Great. So with this motivation, let's go to the next presentation. Satvik, would you like to introduce the next speaker?
Yeah, sure. I'll do that. Yeah, next we have Dr. Sohan Suvarna from IIT Bombay, a very prestigious institution of our country, and he's here to speak about decoding autonomous unmanned airships. He's also a research engineer at the institution, and he's working on development of autonomous airships, and he has obtained his PhD jointly from IIT Bombay, India, and Monash University, Australia. Yeah, sir, I would love for you to take up the conversation and please tell us what you have come here with.
Thank you, Satvik. So maybe I can just start sharing my screen and we can start with the presentation. I hope my presentation screen is visible. Maybe
Yes,
some
sir,
kind of, yeah, okay, all right.
visible. Yeah.
So yeah, thank you for the opportunity to let me speak about autonomous unmanned airships. This is a topic which is very close to my heart because I spent about 5.5, 6 years working on this for my PhD. So yeah, here it is. So this is the brief outline of my talk today. So I'm going to give you a little bit of background about what airships are, what are the issues with airships, and then I'll also talk about the mitigation of some wind effects. And then finally, we'll get into autonomous control. So just to give you a background, airships are these kind of vehicles. So these are on the screen, what you see are contemporary airships. They come in variety of ships, although the popular one is probably the first one that you see. But in the present time, you have a lot of different variations. So you have multi-lobe, which is the one written with buoyant. Then you have a lenticular shape, which is the orange one. And on the top right-hand side, you have a hybrid aerostat vehicle. So you have a variety of designs and configuration now for airships. Now, airships are those vehicles which derive majority of their lift from buoyancy. So typically these airships, they have a gas chamber or an envelope, which basically contains a lighter than air gas. And that is the main source of lift generation. So this airships have more in common with submarines as compared to unmanned aerial vehicles or even aircraft. So that's the key difference between that. Now, why do we have to look at airships? To understand that, let's have a look of the qualitative analysis of various three different kinds of vehicles. So you have multi-rotor or rotorcrafts, then you have fixed wing, and then you have airships. Now, if you look at this, there is the parameter. The comparison is done across variety of parameters. So the first and foremost that is of importance is endurance, range, and payload capacity. So you clearly note that airships have a very high capacity in all of these three. This is mainly because you don't have to expend any energy in staying afloat in the air. The lift generation happens free of cost because of the lifting gases. Although the speeds are low, they can still be as quick as multi-rotors. Performance-wise, they are very, very highly efficient. Safety is even enhanced. Now, this is because even let's say there is some kind of a propulsion failure when an airship is flying. The airship is not going to come down crashing like a multi-rotor or a fixed wing. It's going to gradually descend like a balloon in the air. So probably, let's say maybe a pilot is flying an airship and there is some kind of a propulsion failure. It would probably take him about half an hour to crash. So that's how slowly the airship would descend. The noise levels are very low. So multi-rotors, as you know, they produce a very, very high-pitched noise. And it is around, I think, 80 decibels, which is equivalent to a very busy day in the traffic. Fixed wing also produce a lot of noise. On the other hand, airships do not produce noise because they don't have to depend on their propulsion system, again, to stay afloat in the air. Radar signature and IR signature are both low for an airship. Now, this is because of the low density material and materials which basically have very, very low signatures. That's the kind of material that are used in airships in their construction. Setup time is slightly higher because this would require you to fill helium into the envelopes. The cost is comparable and sometimes even lower as compared to fixed wing or multi-rotors. And of course, the size, as you might have guessed, is larger than the conventional one. So there are several use cases where size doesn't matter or even the setup time does not matter. And that is where it is ideal to use airships. Things like surveillance, which require 24/7 persistence operation and maybe a long delivery of goods in a very, very long distance. So those are the kind of things that airships can do much better compared to their heavier than air counterparts. Now, historically, if we look at the accidents that have happened on airships, so there are 83 up to date. And out of this, you see that the majority has happened because of lifting gas related. Now, I would like to tell you that this was in the early eras of airship before 1950s. And because this was mainly because hydrogen was used at that time. Now, that problem has been addressed by the use of helium. So it's typically helium that is mostly used in airships this day. So lifting gas related problems, you can say more or less has been addressed. But what remains is the problem of instability in bad weather and the loss of control of airships. In short, it is very difficult to maneuver an airship, especially when there is wind disturbances. So that is the key problem right now in the widespread use of airships. So let's understand why that is the case. So as I mentioned, the airships and wind, they don't see eye to eye. They basically, if it is windy, it is often deemed unfavorable for airship operations. So why is that? So on a conventional aircraft, let's say any aircraft you consider commercial airliner, they would have this weathercock stability, which is basically like what we see in a weather vane, that it would align itself in the direction of the wind and face the wind head on. That's what we desire if it has to be weathercock stable. So this is what happens in a conventional aircraft. It would align itself in the direction of the wind. Now you see that it is facing the wind with the full might of its engine. So it's kind of easy for the aircraft to overcome this drag from the crosswinds. But in case of airships, they don't do that. They actually go away from this. So that's the reason why it is unstable. Now look at why exactly again it is directionally unstable. Now, if you look at these two pictures, so one is an airship, the first one, and the second one is a commercial airliner. Now look at the relative sizes of the fin with respect to either its envelope or the fuselage. You see that there is quite a bit of mismatch. Now what you notice is undersized fins. Now it is undersized for many different reasons. It being the location and the weight of the fins that you can put there. Now airship is very delicately balanced, so you cannot put very large fins at the back, so which would make it tail heavy, and then the airship would always be nose up. Then there is the issue of ground handling. If it is too big, it becomes very difficult for the ground handling crew to handle the aircraft when it is on the ground. Also the hangar size. And most importantly, these fins, they have to be mounted on a balloon, that is an envelope. So that is another challenge structurally. So because of all these reasons, you cannot actually have a fin which can stabilize the airship. Now, as a penalty, what we have is that a steady rate of turn. That is basically the airship would turn away from the wind direction, not towards it, as we require it to be stable. So this is the key reason why airships are directionally unstable. Now, let's address these issues with some of the mechanical effects that we can do. So I did this as a part of my PhD work. So this was the airship that was constructed with the methodology that was developed. Now the methodology involved framing optimization problem and then testing it for validation in a wind tunnel setup. So this was that setup, and with that we were able to size a fin which would not make it directionally stable, but at least minimize the direct instability in the system. So that's what we were able to achieve and prove as well. Across the world, there are many different approaches towards addressing this. So for example, some institutions, they went with lenticular shape, which looks like a flying saucer now. And this is one of the ways that they thought of doing this. Although there is a drag penalty when we talk about these kinds of systems. And then we have the famous airlander, which is basically multi-load system. So you put 2 or 3 airship hulls together, and you rely on both the static lift, that is the buoyancy, and the aerodynamic lift here. And then we have a different hybrid configuration, which basically merges the fixed wing and the airship together. So moving on. So now let's get to the autonomous control bit. Now, this is what the control architecture typically would look for any unmanned system, not just for airships. Now, this is how I had designed it for airships as well. Now, I know this looks a little bit scary because there are a lot of things happening here. So I'll address each of them block by block. So let's start with the airship block, which is at the bottommost. So airship block is nothing but the physics of the system. So in our case here, it's the airship. So how would the airship behave when you apply a certain control input or when there is a presence of wind? So that is what airship dynamics captures. And it could be either a real system, if you're flying it on an actual system, or it could be a simulated platform. So in my case, I used both of them. So this is one of the simulations that was done on a gazebo platform. So here you see control inputs are applied and the airship basically takes off and then just moves ahead. So you can see that it has VTOL capabilities. And as you can see, there is no control implemented, and that's why you are seeing that oscillation in the airship. So moving ahead, so that makes the first component, that is the airship. The next component that we have is the control input, that is basically the input that the users would give to control the airship. Then, of course, there is some disturbances which is going to come from the environment. And then we have estimators. Now, what is this estimator? It's nothing but, since we have a lot of onboard sensors, to make some useful information out of it, we need estimators. So this basically filters out a lot of noise in the measurement. It estimates several states which are not directly obtained from the sensors, which is basically indirectly obtained using a model. So you estimate several things like position coordinates, that's the where exactly the airship is in 3D space. Then you have the speed, airspeed, the wind direction and the speed of it, the attitude, which is the roll pitch and yaw angles, the velocities and the acceleration of the system. So that's what the estimator would do for you. And once you have those values, we have the first layer of control, that is the autopilot. Now what autopilot does is, it takes the airspeed, altitude and heading inputs, and then it generates appropriate control inputs by looking at the feedback. So feedback is obtained from the estimator as to what exactly the airship is doing. And then the autopilot would make sure that that is being done. So it's, as I mentioned, a low-level controller. And this is the one that would directly control the control surfaces and the propulsion systems. So the main key function is to stabilize the airship and to maintain and regulate whatever input is given from the higher up, either user or a control block. So it would basically control things like airspeed, altitude, attitude, and course heading angle. So this basically gives us a sense of where and in general direction in which airship should be moving, what is the speed at which it should be operating. So that is what autopilot would ensure. Then the next layer up, we have, okay, so this is an implementation of a control autopilot system. So here we use the mobile operated autopilot. So you see that in this, there is not a lot of oscillation, and you basically see that it's able to hover in one place for longer durations. Maybe I just skip through this quickly. Yeah. So the next layer of control we have is tracking. So this is basically, we have a path defined for the tracker, and it would ensure that it would basically follow that path. And the way it does it, it generates this airspeed, altitude, and heading inputs for the autopilot. So this is what happens here. So let's say we want to follow the red line, but it may not, the airship is physically not able to follow that. Maybe the dynamics of the system doesn't allow it. Maybe there are certain environmental factors like wind, which is not allowing the airship to follow that red line. So that is when the airship would require some kind of a planned trajectory, which is feasible and is also close to the actual desired trajectory. So that is what this would do basically. It would take into consideration the dynamics and then make the airship follow that particular path. And the next one that we have is the manager. So the path manager is basically what we have is, let's say we have several GPS locations or waypoints. The manager would basically make a path out of it. Here also, the airship would consider, the manager would consider the dynamics of the system, and then it generates a smooth, feasible path for the airship to follow. And this becomes the output of the manager, becomes the input to the tracking controller. That is the path definition. Again, so the final layer of control that we have is the planner. So planner is on top of all of these layers of control. And what planner would do is basically generate the waypoint itself. Maybe you could have collision avoidance. If you want to operate this in an urban terrain, there would be a map of the urban locality, basically where there are buildings, what is the point that the airship needs to avoid. And that is how it would generate waypoints. It could also have terrain map, as in like if there are some mountains to be maneuvered across. So things like that would happen in the planner. And this is where there is a potentially artificial intelligence and machine learning play a very good, important role in the planner part of the entire autonomous structure. So putting it all together, what we have is the total autonomous architecture for the airship. And also not to forget is the green lines, which is the interface. So you need to be able to communicate between each of these blocks. And typically, we use ROS for this, robot operating system. It could be used, it can be tailored for different applications, but there are many different ways of doing it as well. So yeah, with that, thank you for the listening to me very patiently. I would be happy to answer any questions if there are any.
Thank you so much, Dr. Sohan. This was an amazing presentation.
Thank you.
I hope there are more questions for you. You
I have a
can
question,
stop sharing the
actually.
screen first.
Sure.
Talk to you.
Hello.
Hi.
Yeah. So I was wondering, these airships generally have really low speed, right?
Okay.
Like, yeah. So would this not like limit many applications of which it is built for having a very low speed? Because from what I've seen, I think they have extremely low speeds and they might affect its applications.
So let me tell you. So the speeds of an airship is comparable to multi-rotors. So this can operate. So in an unmanned sector, with conventionally, we can go up to 30 kilometers per hour in an outdoor setting. So that is the limit that we have in the speed. So this is comparable to multi-rotor, as I said. So many applications we can basically, let's say it is logistics, transferring one good from one point to another, and these 2 points can be very, very far apart, maybe hundreds of kilometers far apart. So that is something that the multi-rotor cannot address. Airships here are the key solution for it. So some applications, yes, they are restricted where speed is of utmost importance. Let's say you want to have some kind of a response system which would act immediately, let's say after some disaster has happened, natural disaster. So in such cases, airships definitely are not the solution because speed is not the key point. But what it provides is basically, there is a gap here. So if you look at the current capabilities of drone, there are several limitations to it. And mainly the most important one, it comes from the endurance. So their endurance is very, very limited. And that is what limits their range as well, operational range. Now, that is what the airship can address. I hope I have answered your question.
Yeah, you answered my question. I'm convinced. And one more thing I was concerned with was the safety of these things. Since they're carrying like these very poisonous gases like helium and hydrogen, aren't they very inflammable? Like if it crashes, won't it be a huge disaster?
So as I mentioned earlier, there were a lot of incidents because of lifting gas. Now that was because in the early era, US had the monopoly over helium, and many of the airships were German made, and they typically use hydrogen for it. Now hydrogen is an inflammable gas. It is something that is the cause for panic for all the airship people, whoever want to use airships. But the current airships that are there, they use helium. Helium is an inert noble gas and it doesn't react with anything. So there you have that added safety. And as I also mentioned, like there is one more safety which is which we call balloon mode. So if let's say the propulsion system fails, or let's say even the balloon develops some kind of a tear, right? So even then the airship will not immediately impact and come down directly crashing to the ground. It's going to be very, very slow. It has a very low terminal velocity and a very low impact energy. So that's how it would come down.
Okay. Yeah, that answered my question.
Thank you.
Thank you. And yeah, I've been closely related to your institution as well. I would like to say, like your UAV team of IIT Bombay as well. Even they participate in the same competition we do.
Oh, great.
So yeah, I just wanted to let you know.
Thank you so much,
How's that?
Dr. Sohan, for being a part of our conference.
Thank you, Dr.
I really hope we stay connected and we learn more. And I'm sure that airships have a great future. But where do you see airships being in a regular commercial activity, like in a day-to-day basis, the way we have quadcopters? How soon can we see that?
That's a very good question. So in India, maybe we're going to take some time because so far, not many companies, maybe a handful of them, 1 or 2 companies who have started working on airships. But you are certainly going to see a lot of airships for logistics, that is carrying goods around. So I'm guessing in the month of November, Google co-founder funded company, LTA Research, they're going to release their airship, which is for humanitarian relief. And then there is Airlander, which is going to again start their operations in goods and logistics. In Europe, there are several airship companies which are using airships for surveillance. Even they're proposing it for, again, logistics. So similar applications we can hope for in India as well, because in India, we do have a requirement for delivery drones. And right now, endurance is what basically cuts off the range, their operational range. I think maybe in the next, if I'm being too optimistic, then maybe 5 to 6 years, we'll have airships carrying goods around. But if I have to be realistic, maybe 10 years.
Sounds good. Thank you so much, Dr. Sohan. Dr. Sohan would be around, so you all can message him and talk to him and connect with him on LinkedIn.
Thank you. Thank you, Dr. Rishi.
Thank you so much. You can move on to the next presentation, Satvik.
Yes. So moving on to the next presentation, we have Sir Chris Daniels, hailing from United Kingdom, and he's the Chief Commercial Officer at Flarebright Limited, and he's here to talk about GPS-free autonomous flight in small drones. And personally, I've encountered with problems with GPS on my drones. So once I was flying a drone that had a PICSOC on it, and it had a GPS, and when I was flying it in the ground and then we went under a building, I lost GPS signal because there was no satellites being recognized from that place. So that time we encountered with this problem. So there are I've come up with few solutions like using lidars or using virtual GPS and all these things. But yeah, I'm very excited to see what Sir has to say, and he's going to also explain how this machine learning digital twins have enabled new capabilities in small drones, particularly flying autonomously when GPS or other systems fail. And and he's a Chief Commercial Officer, like I say, and he has gained a mathematics degree from Oxford University before a 5-year short commission with the Parachute Regiment. He subsequently studied MBA at IESE Business School in Barcelona, and the list goes on. I would love for Sir to explain what he has come here, and would be delighted to see what you have to offer. Thank you, sir.
Great. Should I share my screen? Maybe.
Yeah.
Easier. Excellent. I presume everyone can see that. I'm actually in the Oxford University Maths Institute as I speak in the middle of a meeting, so I've just nipped out to give this talk. And unfortunately, I missed Sohan's talk, which would have been quite interesting because I did spend 5 years working on the Airlander airship project before getting involved in drones, which also originally was planning to be optionally manned. So there's lots of things I can talk about regarding that. But what we're going to talk about today is using machine learning to solve drone challenges. So just as background, the company that I'm Chief Commercial Officer of is Flarebright. We're 15 people, small company in the UK, mainly software engineers, computer scientists. We've got some kind of normal engineers, kind of mechanical aeronautical engineers, and our 2 co-founders, one has a PhD in autonomous systems, the other has a PhD in artificial intelligence. That sort of gives you an indication of who we are. We've had a number of funding streams from the Ministry of Defence, from the US Department of Defence, from the UK government research and technology. We've also won a number of awards, and some of those are on screen, and probably most relevant recently, we were part of Boeing Corporation's Aerospace Accelerated Program for 3 months earlier this year, which they selected 10 of the world's leading AI on autonomy companies to work with them and get involved in their organization. It's a particularly brilliant program. The cohort 4, 4th year of running it, is open now. I'd highly recommend any small companies interested in that to look at that and try and get on it. It's really, really good. So that's who we are. But what do we do? So our premise is that beyond visual line of sight is critical for any useful, commercially useful drone operations in the future. And I think I've probably got a like-minded audience who will agree with that. And this schematic here talks about, well, what sort of things do you need to solve in order to allow BVLOS flight to happen? So right from the word go, before you've even taken your drone off, you need to solve regulatory problems, you need to solve assurance, you need to assure that your drone will work in all environments. And the complex development, particularly with eVTOL and transitions from horizontal to vertical flight, is going to become important. You've got complex pre-flight planning going to happen more and more. There's in-flight things. There's other things that haven't really been addressed too much, like unreliable sensors. So the sensors can break down because we tend to use these tiny little $10 MEMS chips and accelerometers, etc. And they often will break down, and they will often break down in extreme temperatures and in extreme G-forces, which easily can happen in a drone. You have varying winds, and you have some really weird wind patterns near the ground, and particularly at the right of this picture is in the urban environment where you've got skyscrapers and you get the sort of canyoning effect. And then, as you mentioned in the introduction, there's lots of GPS problems. GPS spoofing, GPS jamming, communication jamming, and with interference that will happen more and more anyway. And I think with general malfeasance and the fact it is so easy to do this, I think it will just happen naturally more and more. So those, notwithstanding through life upgrades and expenditure, these are the problems that need solving. So what do? We use machine learning to solve these problems. And why? Because it's quicker. So we can run a year's worth of tests overnight. And what we do in our digital twin environment is throw every conceivable scenario we can do into a really efficient coded environment, and then we can run every wind condition, every angle of attack, every turn angle, every control surface variation, and just throw them all together, and we get a year's worth of tests really well. And we just have a very tiny amount of seed data to allow that process to happen. It's obviously cheaper. We reckon we save about 90% of money versus real world testing and versus wind tunnel testing. And finally, it's more efficient. So it allows you to a lot easier find the optimal approach. There's a lot of things in aviation that are not optimal. Even the design of passenger aircraft is not optimal. It's optimized in terms of cheapness and minimum of changes between variants. We're a long way from creating blended wing, optimal, commercially viable passenger aircraft. Machine learning overlay really allows you to hone in on the optimal solutions, optimal flight paths really quickly. So that's why we use it. So I'll give you 3 examples of how we've used this in the past. So you mentioned GPS fails. Well, this is a trace of, an obvious trace of just from a GPS running watch. And clearly, I ran 2 laps of this loop. Obviously, my GPS showed me that I did something quite different. And if you're in a critical drone environment, this is problematic in that, you know, if you're even 5 meters out of line with where you think you are, you might be crashing into a building, particularly in an urban environment. You might be hitting the ground if you're 5 meters wrong, because they're flying a lot closer to things than other normal sort of passenger aircraft, and you don't have that visual sight. So we take an approach of looking at the whole GPS stack, or the whole navigation stack rather. So we start with GPS, and GPS, when it works, brilliant, and that's a good starting point. At some point, I think ADS-B transponders may well be sort of another solution that comes into the mix. And then what the next layer is, well, can you use vision radar terrain navigation? That's still, when the weather conditions are perfect, that works really well. But often the weather conditions aren't, and often you might be over a body of water. And I just flew from this week from Land's End, which is the bottom bit of Britain, to the Isles of Scilly, about 30 miles away. And they've done a few drone trials, BVLOS trials. You cannot notice which bit of water you're on there. That's impossible. So what we use is this machine learning navigation. And so we've effectively created an inertial navigation system that then allows you to have another layer of assurance and another layer of safety to kick in. And it also measures when all of these systems are working, when they're not working. So that's our approach, is to say we need a multi-layered approach to navigation in drones. And our inertial navigation system, which just uses the normal sensors in a drone, is part of that layer. It's not a unique solution on its own, or it can be for short periods, but it's really part of a layered approach. And how we've done that, so we started off just on a drone that we created ourselves with a box wing, and we've got with 30 seconds of totally autonomous flight on a predetermined program, basically taking, in a very simple terms, and it's more complex than this, but if you think of an accelerometer, the tiny accelerometers that tell you which way up your phone is, those same accelerometers, put them in an XYZ array, and every time you feel a force, that force is the wind, and you can react against that, and then you will know what your position is. So our machine, our flight control system, has trained our drone to know that. We thought, great, that works really well. So let's put that in just a hobbyist drone. So we used an Opteron fixed wing powered, electrically powered hobbyist drones with polystyrene wing, and we ripped out their flight control system. We put in our flight control system, and we've done exactly the same. And we fly circuits and spirals and everything autonomously on predetermined flight paths to a high degree of accuracy using our techniques. And then what we'll eventually do, and we're being funded by the US government and the UK government to do this now, is to put that same system in as many other drones as we want. And it takes us a few months to model all the characteristics of another drone in order to achieve that. And what we've done, and what differs ourselves from pretty much every university project that's tried to look at machine learning systems, is normally the error rate runs away exponentially really quickly. And because we've got this machine learning overlay that models and caps the error, we've managed to create a linear growth rate of error. So we do get an error, but it grows linearly. So we know exactly what it should be at any particular point of time. And that's really important. So that's what we're doing on our inertial navigation system that's got lots of uses in both the defense sector and in the civil sector, and particularly the BVLOS. But if we come back, and I gave a very simple idea of saying we have accelerometers and XYZ array. Well, actually what we do is we take every single bit of data we can. And it's like, and this is why I put this Sherlock Holmes detective character. We kind of think of the machine learning like a detective who every sensor on board any drone is giving away some information, some clue as to what that drone's doing. You know, the temperature is giving some information, the gyroscopes, the magnetometer, the barometers are giving some information. And it's about harnessing that huge data set of information to understand what's going going on in order to use that. And most of this data is only used for single use. It's used for maybe understanding how the engine is functioning, or it's just thrown away as junk data. It's not really involved in the flight control systems. And that's what we use. And even things like current voltage, we do all of this on a Raspberry Pi Zero when it's in flight. So we use the machine learning and train everything offline using pretty much standard reinforced learning technique. Then we go back online onto something as small as a Raspberry Pi Zero, and we control the whole drone autonomously on predetermined flight paths using that. And I think this wasted data is an area that we're really looking at. And these are some actual data from us. When we use all the telemetry from our drones, it really reduces error. So our flight test verified system brings our error rate on the first graph there right down over 30 seconds. So from a normal inertial navigation system based on sensor data, the nav error runs away really quickly, the navigation error, and we cap it because we're using all the data, because we've got this machine learning approach. And then ditto on this other graph, what we've got is actual flight data and you can see how it's still oscillating quite a lot around what we're actually trying to do in terms of the attitude and the speed over time. But we're pretty much tracking exactly what flight plan that we've gone in, which is the kind of dotted square blocks. We're oscillating around it, and as we improve the machine learning, as the machine learning runs over time, it gets closer and closer to the actual answer. And finally, if we look at 3D unsteady wind patterns, we did a really interesting project which is ongoing, has been funded into phase 3 with the UK government, and we've just presented the findings of this project at the International Council of Aeronautical Studies annual conference in Stockholm, about modeling the wind in an urban environment in 3D. And we think that's going to be critical to allow smaller drones to fly in urban environments, whether it's drone delivery or any sort of emergency service kind of monitoring surveillance. And the drones really struggle in gusty environments, and they really struggle understanding round, and this is central London, but you know, the winds around one side of the skyscraper are going to be very different to the winds around the other side. So we did a project at Cardiff International Airport where we worked with a computational fluid dynamic modeling company called Xenotech, and we were looking at the wind vortices coming off this massive British Airways maintenance hangar. So you can just see the people in yellow high vis vest, that's our team, with a windsock and an anemometer just to measure what's going on at about 3-4 meters. And our drone flies, and because it understands where it should be, and it's react against the wind to stay on that same flight path, you can back solve that to measure exactly what the wind is. And again, that's a function of our machine learning approach offline. We know exactly what the wind is to a really high degree of accuracy at all times. And as I said, we can put this in any other drone. So as you're flying, you will know what your wind is without a pitot tube, without anything else, just from these sensors in your drone. And as you can see in the top diagram in the middle, we're absolutely seeing crystal clear where the vortices rotate and the wind comes from the other direction. And then when the wind's blowing towards the hangar, as it was on a different day, we get this really smooth airflow in the bottom. But what's even interesting there, at the very bottom, we can see a little bit of wind shear, and that was between 3 meters and 4 meters. We're getting that level of granularity just with bits of ground effect and sort of wind coming off some of the fins of the large aircraft that were waiting to go into the maintenance depot. So that's just an interesting kind of side effect of what we're doing. And where our machine learning ecosystem is going with this is looking at mission optimization, in-flight failure monitoring, especially GPS spoofing and denial, degradation of sensors, degradation of performance, rapid development. We're getting heavily involved in GPS-free navigation, both for BBLOS and for military and for wind sensing, as I mentioned. So that's us really. Hopefully that's a quick whistle-top tour about how we're using machine learning, digital twinning to solve real-world BVLOS drone problems. And I'm happy to take questions for a few minutes.
Thank you so much, Chris. This was an amazing presentation. I really, really enjoyed it, and I'm sure everybody else has also enjoyed it. I request everyone, anyone who has questions for Chris can put it in the chat, or they can do a hand raise. Meanwhile, I want to ask you, Chris, what kind of data would you need from a community like ours to strengthen your machine learning solutions that you're trying to create? What can we do for you? How can we be a part of your solution?
So what is really useful for us is any real world flight data that comes off any regularly in use drone. We can take that data and we can model it, and then we can sort of work out what's going on. And one of the challenges we've got is if we're working in partnership with another drone company, which typically we will do in defense, we'll typically get all the data off their flight control system. If it's a more commercial drone, you know, a DJI drone, whatever, typically we won't get that. So if people have kind of already extracted a lot of the telemetry data from that just for their own use, that's really useful, because then we can go ahead and just start modeling things. So yeah, but I think at the moment, all data, what we're finding, I was just at the end of Masters of Science program at Cranfield University, where they're doing a lot of work on autonomous systems, etc. And all of them were really struggling with having real world data sets that they could utilize for all sorts of purposes, not just the kind of stuff we do.
Great. And is there a way, I mean, if let's say we have a community of young drone pilots who can somehow contribute to what you're doing, can that be worked out somewhere?
Yeah, so actually we should, if you send your idea or your thought to info@flarebright.com, that will get through to us. And we're a small company, so it doesn't go through layers and it doesn't get ignored actually, and normally it comes to me. So we're more than happy. But if we see that there's enough people out there sort of with these rich data sets, we'll set up an online way of kind of recording that. And what we really want to do is make sure that that's open data. You know, we're not trying to kind of hoover stuff up for ourselves. We want, you know, I think if we could put an open source data set for everyone to use, that would be really useful.
Great. And what have been the major challenges that you faced while building this platform?
The number one challenge for any small business in the drone world is funding. It's not technical, it's not anything else, it's funding. So we've solved that problem mainly, but that's still always a challenge. The number two problem is regulatory, and that's one of the reasons why our first drone was this 85-gram super small drone, that's sort of, you know, basically a bit bigger than a cricket ball, because regulatorily it's a lot easier. As we get into bigger drones, particularly on BVLOS, it becomes a lot more of a challenge. So, you know, those are and I think that's consistent with pretty much every drone company in the world. Get the funding and get the regulation sorted. Everything else is actually relatively easy.
Great, thank you. Anyone has any more questions? Satvik?
Yeah, I would like to say a few things. So actually, I'm a part of the UAV team of my college. So talking about how you were asking data or data sets that you would like to have. We regularly fly our drones in India, in our fields in Bangalore. And yeah, I would be more than happy to contribute or work with you in general. If I could get any contacts on where I can provide this data or where I can contribute.
That would be great. So we'll look at a sort of system. I mean, it's a really good point, and I think we'll look at a system of how we do that, and presumably through yourself or Rishi, we can communicate that to everyone.
Yeah, sure.
I'll add that to my to-do list for next week.
Okay. Yeah, your
there is a question in chat. There is a question in chat before you wrap up. What are the prerequisites for a drone manufacturing startup to make the machine learning adoption easier?
Get super clever machine learning people in your company. There are no prerequisites, and a lot of it is trial and error. And our co-founders spent 30 years doing subsea autonomous systems. They sold that company successfully. That allowed them to set up Playwright. So, there's a lot of just learning and understanding what works and what doesn't work. I don't think there's any magic, I couldn't give you a magic list of sort of, you need to do these 10 things and that's your route to success. Here's my golden rules. It's hard work, understanding machine learning intimately, and trial and error, and working out what works and what doesn't work.
Great. Thank you very much, Chris, for coming to our conference. We are extremely obliged that you're here with us today, and we hope to keep learning with you in the future as well.
Thank you. Thank you for inviting me.
Thank you, sir.
It's been great.
Thank you.
Cheers. Thank you then. Bye.
Satvik, you can introduce the next speaker.
Yeah, one second. Ma'am, can actually you do it? I'm having few issues with my connection.
Great. Hi, Gemma. How are you?
Thank you. How are you?
Let me introduce you. So we have Gemma Alcock. She is the founder of Skybound Rescuer, and she has been saving a lot of lives in the United Kingdom and teaching everybody else around the world how to do it with drones. Gemma, welcome to our conference, and we really hope to learn from you a lot today.
Thanks for having me. Right, I shall share my screen.
Yes, please.
The presentation. Cool. So hopefully you can see that.
I can see that. Perfect.
Well, hi everyone. I'm Gemma Alcock from Skybound Rescuer in the UK. And today I have some really exciting plans and research results to share with you. And then at the end, I will be premiering a video that will bring those plans to life for you. So I hope you're as excited to hear about and experience our plans for the future of search and rescue as I am to tell you. But first things first, you need to know who's talking to you. So who am I? I'm Gemma Alcock, and I have two roles within the drone world. Firstly, I'm the founder and CEO of Skybound Rescuer, which I'll come back to. And secondly, I'm the director of air operations for Lowland Rescue, which is a UK charity that searches for missing vulnerable people on behalf of police forces. We have 36 teams across the country, just under 8,000 volunteers. And as my title suggests, I manage the air operations. So how we interact with the search and rescue helicopter services to how we use drones to find missing people too. But today I'm speaking on behalf of my company, Skybound Rescuer. So who is Skybound Rescuer? We are a team of experienced emergency managers that specialize in the use of drones for public safety. So since founding the company in 2016, I've been researching into best practice for every phase of drones for public safety, from training to competency management, to drone procedures, to mission tactics, and everything in between. Until recently, our services included research and consultancy for drone tech companies that wanted to explore public safety, and for emergency services wanting to explore drones. But since December 2020, our business as usual has been changing. We've been working on Skybound Rescuer 2.0, which is what I'll be presenting on today. I promise you it's truly exciting. But first things first, I need to describe the problem that we are looking to address with Skybound Rescuer 2.0. So, it is undeniable that air support in all of its forms is an integral component of modern emergency services, offering better situational awareness for enhanced safety and saving valuable time when it matters most to ultimately save lives. However, there remains significant challenges with the current air support services. And these causes and problems will be something that every emergency service around the world experiences every single day. I've included some UK specific stats on this slide to contextualize these challenges for you, but these causes and problems are not contained to the UK alone. Firstly, the expensive nature of manned aviation is causing low availability. For example, police helicopters across England and Wales are available on average 54.9% of all requests, meaning that the police helicopters decline almost half of their requests because they are unavailable to respond. They simply cannot meet their growing demand. Not only are the aircrafts expensive, but so are the helicopter bases, which means they're few and far between. So, for example, there are 10 Coast Guard helicopter bases to cover the 2 million square miles of the UK search and rescue region. This, combined with the very manual request process, is causing slow response times. And the slowest average response time in the UK is experienced by Cumbria Constabulary, which is 66 minutes, even when there's life at risk. And then we come on to manual drone teams. Now, although the potential for drone technology is undeniable and it's growing in evidence, performance data and research trials have been revealing some performance concerns. So, first of all, at the moment, we have relatively small drone teams covering very large areas. In addition, they cannot, in most cases, fly direct to the incident site. They have to drive the drone by vehicle to the incident before setting up and flying. And this is causing slow response times and low availability. I've personally been involved in searches where we have had to wait hours to days for a drone team to be on site. A drone is rarely the first on scene, and yet that is where they'd add the most value. And lastly, local teams around the world have been working in silos when setting up their drone teams, which means there's no shared national or international standards for the drones they're using, the training they receive, the mission tactics they follow, and everything in between. It can differ vastly between two emergency services operating in one county, let alone nationally or internationally. And yet, the importance of joint emergency service interoperability is so well known and proven in this space, and it's causing varied, unreliable performance levels with drones. So, all things considered, air support is often the greatest advantage to an emergency service because of its high height of eye advantage and its real-time situational awareness picture it can offer. Therefore, these challenges that I've gone through are causing greater levels of risk to the public and to the emergency services through inefficient air support. So if an aircraft is unavailable to respond or too slow to respond, then our emergency services are having to proceed into dangerous environments without an eye in the sky to protect them. Or they're having to spend hours searching an area that could be covered by an aircraft in minutes. And this is the problem space that we're looking to address with Skybound Rescuer 2.0. So the first part of solving this problem was developing our new automated drone software, the Drone Mission Coordinator. Since December 2020, we've been turning our 7 years of research and data into an algorithm that can automate data-driven decisions for public safety. And the first use case we've been focusing on is missing person searches, which pulls on a variety of databases such as missing person behavior statistics and data from our own trials into things like optimal flying heights, optimal flying speeds, and more, all to better find missing people with drones. It also quantifies performance because no two searches are the same. For example, we could be searching flat terrain with cut grass in daylight for a person wearing bright red clothing and in a high-vis vest. And then we could be searching hilly terrain with tall vegetation in darkness for a person wearing dark clothing. These two searches will not have the same performance. And yet using current terminology, we say that area has been searched by a drone and that area has been searched by a drone with no instant indication of those differences. But using our software, you'll be able to quantify those differences so that a search manager can make informed decisions about whether that search was sufficient or whether the drone needs to repeat that search but with different flight parameters, or whether they need to send a different search asset altogether, like a foot team. This software is packed full of many other pre-flight features, all informed by our research. It's also packed full of many in-flight features that enable teams to collaborate more easily to find missing people. And then it also generates a automated post-flight report that summarizes and analyzes the performance. We also wanted to ensure that no formal drone training was required to generate these plans, so that someone in a control room that never seen a drone before can create an informed drone mission plan as easily as an experienced drone pilot. So the process for establishing one of these mission plans in the Drone Mission Coordinator is a simple request form that requires instant intelligence only, and it takes a mere 2 minutes to complete. But this software is one piece of the puzzle. It addresses the need for standardized, repeatable performance, but it doesn't address the need for faster response times, the need for cost effectiveness, and the need for better availability. So allow me to introduce you to the bigger picture, the Emergency Drone Network, or EDN, as we're calling it. So we are rolling out a network of automated drone stations in hotspots of risk, such as popular coastal locations, whereby any emergency service can task the drones on demand through our software to save and protect lives. So our software, the Drone Mission Coordinator, aims to unlock this EDN vision. By using automation technologies, the drones can always be ready to respond, and there will be no need for an on-site drone pilot. This, combined with being placed where they're most needed, means we're aiming to deliver a 5-minute response time in these high-risk areas, which is 55 minutes faster than the Coast Guard helicopters. It also aims to be the most cost-effective form of air support by being, firstly, a shared multi-agency network, but by also reducing the amount of human power required by each agency. But also, Skybound plan to retain ownership of the network, and the emergency services lease the use of the drones instead, removing the capital costs from their budgets and making sure that they always have access to the most cutting-edge drone technology. And then if we compare the affordability of our infrastructure to helicopter bases, we can have hundreds across a country rather than double digits, which will improve availability and response times, making sure that there is air support available in these high-risk areas when it matters most. And of course, through the Drone Mission Coordinator, the decision-making will be repeatable, it will be automated, and it will be data-driven through our 7 years of research in order to standardize performance to a high level every single time. Before I get to premiering a very exciting video, I'd like to demonstrate the value of Skybound Rescuer 2.0 by sharing some exciting research results with you. So I'll give you a few seconds to take this slide in, and then I'll go through it with you. So the column on the left is our performance. We took 8 minutes, 1 second to respond. We took 13 minutes, 39 seconds to search a 0.25 kilometer squared search area. And it took one person, and that one person had no formal drone training. In fact, he's never even touched a drone before. And importantly, we had 100% search accuracy across all of the tests too. The column in the middle compares our results against a foot team, and the column on the right compares our results against a manual drone team. We tested them under the same conditions. It was same search area, same search target, same search scenario, all things were equal. And as you can see, we responded significantly faster than both. We searched the area significantly faster than both. We reduced human power significantly for both. And in the case of manual drone teams, we also improved search accuracy. Now, speed in terms of both response time and search speed often act as proxy metrics for survivability. The faster we can get there, the faster we can find them, the faster we can deliver them to definitive care, the better the chance of survival. So these results demonstrate the truly life-saving potential of the EDN and our Skybound Rescuer 2.0 plans. Now, to really bring this to life for you, hopefully the sound works for everyone, but I'd like to premiere our Counting on Drones concept video that paints the picture of the future we are striving for.
We count on our emergency services in our darkest hour. Now we want to be there for them. A network of automated drones that our heroes can count on. Air support keeps them safe. Air support keeps us safe. Air support can make all the difference. Because the people who are brave enough to keep us safe deserve our support. Counting on us. Counting on drones. Counting on the emergency drone network.
Cool. Hopefully the sound worked for everyone, but if not, I think the story still makes sense without the sound.
We all heard them, I think.
It's not allowing me to go to the next slide, but there we go. Okay, so thank you for listening. And I hope you're as excited about the future of search and rescue as we are to create it. But yeah, I will now take any questions that you might have, and then I'll stop sharing the screen.
Yeah, I have a question. So from countries like India or other third world countries, like or any other UAV like-minded organization or a student team, so what would you ideally expect from or would like for us to contribute to you to make this even better in any sense?
It's a good question. So I think one of our challenges at the moment is identifying these hotspots, and local knowledge is very important for that. Whilst we're identifying those hotspots at the moment in the UK, that's obviously where we're based, so it's somewhat easier to do. So I think a key kind of collaboration with other countries is to work with people to identify where those are, because quite often if you live near, say, a hotspot in terms of a dangerous beach, you'll be aware of it. Hotspot in terms of a crime hotspot, often the residents are those that know about it best. So that's a key area. As we're trying to make this more and more intelligent, at the moment we've got the algorithm creating the mission plan. The next stage will be to also run an AI over the imagery to start locating people. So that's an area that would be really good for collaboration as well. Not only to build something that can do that, but it's going to need a lot of imagery to become very intelligent. So those are key areas at the moment that we know that are going to need a lot of collaboration to refine.
Right, that answered my question. Thank you very much.
We can have Ashwini Sharma sir next to ask the questions.
And how can we contact you?
So the email at the end of the presentation is skyboundrescuer@gmail.com, or me personally is gemma@skyboundrescuer.com.
Hi, Gemma.
Thank you.
That was a lovely presentation. Very well done. Now, I would like to ask a practical question as to the all-weather capabilities of these drones. You see, in thick fog or or very adverse weather conditions, would these drones be as effective as they are in fair weather, and or would we have to finally use the drones only as a part of the mission, and the rest would be then carried out by humans or people on foot or in vehicles, etc.? Thank you.
Yeah, I think the answer to that is kind of multifaceted. First of all, we are hardware agnostic. So when we are identifying these hotspots, one key thing that we're reviewing is weather data for that particular area. And if we identify that, say, a Mavic, like was in that video, wouldn't be able to fly for the majority of the year, then we start to look at a different aircraft, a different station in that particular location that meets the requirements, not just in terms of the use cases, but also in terms of the weather conditions. So that's one thing. The other thing is that we are not trying to replace helicopters. There are significant challenges with them because of the cost of them. So we're kind of looking to fill the gap, either in terms of being the first response and then they come and do the rescue. But also when we cannot get around the fact that these multi-rotor drones are not going to be as tolerant to weather like a helicopter. So when there are cases where we cannot respond, we fall back to what we've got right now. We're also not trying to have total coverage of a country. We're identifying the hotspots that need the rapid response. So in between those gaps, we can still use manual drone teams, we can still use helicopters, and then failing aircraft in general, because there's still weather conditions the helicopters can't go out in, then we go back to foot teams and water teams. So we would never be the only solution to rely on in a particular area. But so it's a mixture of, having that concept of operations of when we can't fly, having those backup plans, but also identifying the right equipment for that particular area as well.
And a follow-up question, if I may. What about the terrain data and the other information for that hotspot? Is that all pre-programmed into the drone itself, or it's in a ground station where the operator who is controlling is going to, direct or navigate the drones for the rescue mission?
So those stations are going to be in static locations. So actually, before we install a station there, that's when we're working with a third party that specializes in, actually before this, they were finding good places to put mobile phone towers. And now they're working with us to identify a good place to put our drone stations. So those will be in a static location. So a lot of the analysis of that location will be done before it's operational there. And we're almost creating like a digital twin of the environment we'll be flying in, so that not only from the weather perspective of making sure it's viable to put there and making sure it's needed there, the drone can also make intelligent decisions around safety as well, to know not to overfly certain obstacles and how to navigate the environment that it's in, because they're going to be in a static environment. It can have like a 2-kilometer range from that box, which is the case for the Mavic. So we can have almost a map of that, and it can make very intelligent decisions because it will know its environment so well.
Thank you, Gemma. Thanks.
There are some questions in the chat, and I'd like to put these across. Are the best stations tracking closures you deploy also capable of enabling multi-hop missions, since there will always be an endurance constraint compared to a helicopter?
Sorry, I'm just reading the other base stations being deployed also capable of enabling multi-hop missions. So just to make sure I've understood, so a drone could take off from one station and then land in a different station. Is that what you mean by the multi-hop? Is that right?
Maybe Mayank, you can unmute yourself. Mayank, you can ask your question.
Oh, hi, thank you. Yeah, so my point was that let's say you deployed along the coastline, right? Compared to say helicopter-based solutions, endurance will always be an issue. And if initially you might have a sparse enough deployment that you might not be able to have enough endurance to carry out search over the entire area. So the mission planning that you're using, does that allow for one drone to piggyback or like take over the mission from where the endurance of one goes off? Because I'm assuming you have charging stations in these base stations, but what about the cases when, for example, you need a multi-hop scenario to be able to actually cover an extended range? Or let's say you have, instead of every base station having a circular radius around it that gets covered, you want to share areas which have already been discovered or mapped by the previous drone. Like, is that something you already handle or are planning for?
Yes, so we have been testing that. That's almost like a next step for us to, it's like a future problem to have once we've got enough stations that becomes a requirement. So that is one solution that we could do if we're using a small multi-rotor, or if we realize that a particular location needs a longer range because they need to patrol a very long coastline. That's when we can look at a VTOL instead of a multi-rotor.
Of course.
As I mentioned, we are creating the configuration station around those requirements. So that could be a potential, the kind of multi-hop, or it could be that it needs a VTOL in order to patrol there.
Makes more sense. I had a bunch of more questions. Is it okay if I just ask them? I posted them in the chat already. Yeah, I was curious to know that the concept looks great, but where is the UK at in terms of the legal frameworks or the safety security frameworks being in place for you to start operations today? Is that something you can start like as of September 2022, or is that still a couple of months away, or how is that looking for you?
So obviously regulation is the biggest challenge to most drone innovations right now. So we are not alone on that one. So we have a roadmap for enabling it. And we are actually in the process of setting up a station on a private island so that what is key to that safety case is repetition, track record, and show that we can do it safely before we do it near people, near structures and things like that. So we are in the process of setting up a test station to get there. The first stations that we are setting up are within visual line of sight to the hotspot. So for example, we've got one here where I am right now, that is 300 meters visual line of sight to a bridge, which unfortunately is a suicide hotspot. We can add value even within a standard permission. Yes, it means that we need to have someone stood there and stationed there when we're operational, but we're moving through that roadmap. If we don't start like that, then we'll never get to beyond visual line of sight. So yeah, we're in the process of building that track record.
And one last question, sorry. The way I imagine your EDN is kind of similar to, say, these Lime scooters, which got really popular, like the electric scooters which were there, considering like there's so many spots where I can imagine a distributed EDN network with like hopefully a very large enough density of nodes, especially in emergency spots, like you said. But then doesn't scaling and logistics become a nightmare, and you kind of opening yourself up to the similar challenges faced by these normal commuter scooter companies? Like tampering could be one, reverse logistics to handle failures and kind of replacing dead drones in the field could be one. And considering your company bears the entire cost for that, is that the approach that you're taking for scaling right now, or are there tie-ups with third-party companies or things like that? Like, how is the scaling aspect structured for, again, like you said, this is a problem for when you have enough nodes, but I wanted to understand your approach to scale for that.
Yeah, so there's going to be several challenges with the scale up, especially around the security of the site itself, which are things that we're designing our stations, and it will have CCTV and it will be as secure as we can make it as well. Like some of the locations are going to be on rooftops, which are much easier from that perspective. Some of them we are going to co-locate with police stations, fire stations, ambulance stations, which also makes it somewhat easier. but there will be some that are on private land that that will be a challenge. So yeah, it is not one that I have a definite answer for, because it's actually quite specific to the location, and making sure that we have measures that fit the risk score for that.
Yeah, so that covers the security part, but my question was also regarding things like maintenance. So like, let's say you have drones failing in the field. Would you imagine having a large enough workforce of people going in trucks to those locations and actually getting those back or replacing or repairing them? Or is there any thought to maybe enabling local communities to enable them, or say area in charges who could do it in a more federated sense?
Yeah, so I think in the first instance we would do it in-house, but there will become a tipping point where we'd look for third parties to partner on, say the maintenance schedule would be a key one. So I see it working similar to the telco industry over here, that OpenReach is a company dedicated for maintaining repairs and things like that. And then maybe we upskill someone like OpenReach to do that for our service as well. Because yeah, it would take a significant workforce across the UK, let alone we scale internationally. So we don't expect to do every single part of it in-house, but to start with, until we've got the knowledge, then we can then train someone else to do it.
Yeah, thanks a lot. And that's all the questions.
Gemma, we have one more question for you. Environmental constraints. What are the environmental constraints that might challenge this kind of operation, and what could be the development in overcoming them?
Is that environmental in terms of weather constraints or environment? So I think I've gone through the approach with the weather constraints. So I assume this might be, say, if we're close to wildlife. So because we're bringing in lots of data sets when we are reviewing different areas to put them, this is actually one of the data sets that we are bringing in, so that we're not within close proximity of a location that will disturb wildlife. For example, there's over here we have the National Trust, which is lots of wildlife within these areas, and they're protected. So we're also making sure that we are not overflying areas like that. So that's going into our basing configuration plans.
Thanks a lot, Gemma, for coming to our conference. I believe these are all the questions we have right now for you. You're most welcome to stay back at the conference and interact with others in the chat. And everyone, please get in touch with Gemma, and I'm sure she'll be very happy to help all of us the things that we have. And Gemma, all the best for all the amazing things that you do. I'm a super fan of your work, and I'm so glad that you're here today with us.
Thanks for having me.
Thank you.
Thank you so much, Jenna, for that interesting presentation. I had actually one final question to ask, like, what are the parameters that are embedded into the drone when flying? Like, how do they identify the different persons they're supposed to rescue? And are the drones able to work at night, like to rescue people at night?
Yes, so at the moment there isn't a automation that selects the missing person, because we need a lot more data for us to start relying on that instead of having human eyes on the screen. So it automates the mission plan around how many pixels the person needs to be on your screen for a human eye to detect and recognize that as the missing person. In the software, you upload the missing person details as well. So all of the remote viewers have a reference point of what that person looks like. Because there's a lot of false positives in a search, is in like, oh, it's like stop start, like, is that the person, is that the person? We've also got it that you can interact with the video, not just the drone, so you can pause the video and zoom into the video rather than having to pause the drone, because then your battery endurance will deplete and you might not be able to cover the whole area. So that's how we're kind of doing that at the moment. We can stream it out to as many people within the search team as possible, so you've got as many eyes on it. And moving forward, we will start to have an AI that's assisting them, but it's quite a way off before we rely on an AI without a human watching it. In terms of at night, so we have a spotlight on the Mavic drone. It has a thermal camera as well, but we are more restricted in terms of the regulation because of the risk is greater. So for that, it's more closer to the station, that it's not a large search area that we would do. So there are some restrictions, but it does work at night.
Thank you very much for that. I'll move ahead to.
Thank you so much.
Our next presenter is Nishant Singrana, and is going to talk about unmanned robotic operation optimization. Nishant Singrana is the CEO of and founder of Various, an unmanned robotic software startup, and he's going to give us a brief history of how the hardware and software industry is according to the drones technology. Mr. Rana, the floor is yours.
Hello, can you hear me? Right, I was not able to unmute myself, no worries. Cool, can you guys see my screen? All right.
Yes,
so,
you can see the screen.
Thank you so much. Hi everyone, this is Nishant, and I'm the founder of Various, and we are seeking to transform the unmanned robotic infrastructure in a pretty similar way to what AWS kind of did to cloud computing, where now everyone can build applications, put them online, and then people can directly interact with them, and they can just go and focus on doing business. So this is exactly where we are coming from. We actually started as a company which are actually doing drone deliveries. So when we started, we were already running a lot of operations. We understood the nightmare that it's going to be once you have multiple robotic systems working together. Then you have like humans taking care of it. We realized that the entire segment of unmanned operations is basically segmented. Only 30% of the operation that we were basically running was done by unmanned systems, which was essentially just replacing a human operated vehicle to something that can actually just do its own work. But then we realized the 70% of the backend work that was still required. This could be the piloting, the compliance issues, the maintenance part, the management of assets, the orders, that was all being done by humans altogether. And in our understanding, that was basically defeating the entire purpose of creating an unmanned operation altogether. So what we realized was that, when enterprises starts adopting these systems, the major challenge will not be just to prove that these work, but rather how they, integrates backward more robustly into their existing workflows. And this is exactly how we got to this question of how you actually manage and scale a fleet of multiple drones, mixed drones, which an organization can any point of time choose. So the bottom line came to the point where the entire operation became specific to how pilots, which are the humans, they engage with them, how the safety of the entire operation is handled, how telematics and reporting is something that can be automated, and then the regulatory compliance basically becomes a seamless. So with that understanding, we realized that any organization out there will need to take care of a few segments, which are going to be like, doing undifferentiated heavy lifting altogether again and again. Because it doesn't matter who you are, what you are doing, what kind of OpEx you are running. 4 segments, which is the transparency, security, scalability, and cost, will always remain the same. And it will also not matter the kind of drone you're operating, how it looks like, how it works, because all of these segments have everything to do with how it connects backwards rather than what is actually do, right? So we then realized that for all these 4 different segments, you will require specific tech stacks. which are either non-existent or which are basically scattered across different places. And then it becomes really harder for organizations to understand how they can automate it all together and bring them all together. So we thought of basically bringing them all together under a single umbrella in sort of a system or a solution which is completely agnostic of the organization's hardware need. So we basically then came up with a solution which we are now placing as the AWS of unmanned robotic operations out there. We are saying that we're creating this AI-enabled plug-and-play software architecture, which is meant for all autonomous mobile robotic systems. But definitely, we are basically targeting drones at this moment. But the idea remains that it essentially provides the capability for these organizations and manufacturers to have the flexibility to choose any hardware at any point of time in their entire life cycle. How it allows you to essentially remotely manage your entire system's reliability, even with increasing fleet sizes and team sizes, basically how the humans and robots work together, literally work together. And how we can actually automate and digitize this maintenance processes that, essentially right now doing completely manually, but you have so much data, the data which is actually hard to process humanly, but you can actually utilize that to basically provide predictive maintenance altogether. And you can reduce, mechanical failures and control errors as well. Data logging, which is a huge part of this entire puzzle. I mean, if you look at the aviation industry, then they require you to have black boxes on the planes, right? Because those black boxes actually have all the data. So we understood that this is something that is also required, but then you have to automate it. You have to digitize it completely, so it does not become a bottleneck in your entire operation. So we started thinking about how we can completely automate the data logging, as well as provide a very streamlined integration with the compliance processes. And last but not least was the point where we understood that the maturity of customers is already at par when you compare it with existing solutions or manually done solutions. When you book an Uber, you expect to understand, who is driving, what's the ETA, what's the path the Uber is taking. But as soon as right now you book anything, maybe a drone survey, an agriculture, or maybe delivery, you have no idea, because the entire OpEx is completely surrounded and focused in terms of how the operations team does it, and the client can be just at the sidelines waiting for the final outcome, which is something the transparency which is basically lacking altogether. So with that, we realized the value that essentially we wanted to create was coming from the fact that we basically wanted to provide a capability for lesser number of humans to control more number of drone systems. And with the stack that we created, we are basically now able to control 6 drones simultaneously via a single pilot, and we can definitely move it from there on, building some really complex algorithms that will provide a collision avoidance, fleet management, and all together. So we realized that the mission planning is something that is a huge part of the entire OpEx, and we basically then worked on to create tools that can actually reduce the time that essentially goes into the mission planning time. The management coordination of the backend team, it could be a manager, it could be a supervisor, their transparency, live tracking, all of that is something that is completely missing. So we worked on that. And finally, we basically worked on the errors troubleshooting compliance, and we were able to basically reduce them by 98% with the pilots that we did. So in a bottom line, what we essentially targeted, and then we got to the point, was that we basically wanted to streamline operations and in security, provide higher scalability and the visibility, and increase the overall productivity of these systems, not for the third party, but for you, for the operator who's actually utilizing these systems to run their own operations. And this way, we made sure that we take care of this undifferentiated heavy lifting that I just spoke some time back about, so that our customers can actually take care of their customers, which is the operators can solely focus on operating their fleets, and just focus on how they can economically reduce the entire cost of running an unmanned operation altogether. So just to quickly give you a gist of the product. So the product that we have built is basically this entire layer, which is hybrid in nature. So it's a software which gets installed in computational devices, and the rest of it works on the cloud. It provides for real-time visualization combined with robotics management analysis capabilities. It's a no-code platform, and it brings all the scattered text together. Considering it's a hardware agnostic platform, so it is supposed to support all autonomous robots. And I think as we move forward, we definitely be able to increase the number of systems we can control. Right now, if you're building anything that goes from PX4, RDPilot, PixSox, DJI systems, it supports all of them. So if you bring a PixSoc, a DJI, and an RDPilot, put it all together directly and ask me to fly them just by myself, then answer is yes, I will be able to do so. Just to quickly run you guys through a case study, we essentially were, honored to be a part of South Asia's first live commercial beyond visual line of sight vaccine delivery operation. I think they already spoke at the event. We basically, flew drones 16 kilometers apart, carried vaccinations for patients, were able to reduce the time from 1.5 hours to 16 minutes. But what is most important is basically the entire collaboration that happened with AAI, DGCA, manned flights, ATC, as well as Indian Army. And what we realized was that this entire, puzzle within the sector about, having unmanned and manned operations happen simultaneously can actually be pretty much rectified the way that the data can actually flow bidirectionally. From the ATC to, let's say, the fleet management software side, all of that can actually be handled through a third-party UTM player that can actually be taken care of by the digital sky itself. And it doesn't actually matter if you have transponders, if you have ADBS. I mean, all of the data can actually be synced together. I mean, this is something that we realize, and this is actually something we are now working on to streamline for the entire industry. So I'll just quickly go into a little bit of detail about what we do and what we provide, and then I'll open it up for questions. So the first thing that we provide and we target is basically the control and commanding. How we do it is we remain completely agnostic of any communication channel that you want to use, RF, tethered, Wi-Fi, LTE, 4G, even 5G now. We are now the official partner for Nokia 5G. And if you want to basically directly integrate your drones with their 5G core, that can actually happen directly through our software layer. What we do is we basically bring all the UTM data, the weather data, as well as the weather parameters. You can bring multiple robotic systems simultaneously together, control, like I said, 6 together. And we also provide you 3D visualizations within the platform itself. So while your drone is flying, you cannot see it, but you can exactly see the path as well as the way the drone is going to be behaving. Once, let's say, the piloting is done, it is sorted, then comes the part of the operations team, the team which is actually sitting someplace else, and they actually have to take care of multiple such drones flying, multiple operations happening across the globe. And we basically then have to take care of, how the backend segregation happens, order management happens, pre-flights, post-flights, how log files are stored and stuff like that. So all of that can actually be managed via this platform. We allow the management team to basically segment their entire operations into ecosystems, hubs, and stations. And this allows them to essentially have a micromanagement happening within their platform. And just like you do in the real world, you can have managers to do that. You can actually have those managers virtually within this platform altogether. And this essentially, provides you complete transparency in terms of what is happening across the globe with your assets, while providing you data analytics while your operations are running. So if you just ask me, which drone is doing, most of the work, or which pilot is doing most of the work, we can actually directly tell you without you needing to go, into any Excel. And you don't have to put in any data at all. It's all automatic. So let's suppose once the management is done, comes the part of maintenance aspect. Then we take the data from the drone, and through our systems, we utilize that to provide you understanding of your entire fleet. So we can directly tell you a summary of all the systems that you have, which one is good to go, which needs maintenance, and which you need to tweak or understand a little bit more about. And furthermore, we can basically do that even for your landing pads. Batteries are the biggest asset in the entire operation, and these are the kind of perishable asset that you need to understand how they are doing, and you have to optimize them based on the cycles. And we can actually do that directly for you without you needing to basically go into any sort of data at all. So these are the kind of things that we realize and we are still working on. And while we are understanding from the industry, we are basically trying to make it more comprehensive, if I put it like that. The last thing is basically what we realized was the gap in the training and certification aspect. What we realized was there were so many different simulators available across the globe. We basically wanted to create something that's highly accessible and can actually be just used at any device altogether. So we created a cloud-based sort of a simulator which introduced student management analysis capability. So this allows any organization to basically, hop in and have their own, 15 different levels, have the pilot go through an entire journey of understanding and learning through those 15 levels. And while the pilot does that, we basically, are able to grade them, store all the data that they have, and also, disperse a very digital certificate pretty automatically, having your organization's credentials on it, so that the pilot can actually now move on to the real world drone flights with lesser, drone crashes. So this is the entire sort of a setup that we created. And the last thing was something that's more of a order management or an ordering engine, which essentially allows anyone, any of the developers, any of the companies to basically build their own portals connected backwards directly into our network, and then completely digitize the way that they basically can, create orders and, bringing live tracking backwards to the clients. So yeah, that's it. That's what we do. I'll talk a little faster because I basically want to understand and learn and hear from you guys as well, answer a few questions. If I put it in these words, then what we are creating, we believe, has a very similar potential to revolutionize unmanned robotic infrastructure in a pretty similar way to what AWS did to cloud computing. And we would love to have you guys on board. And the idea is to basically democratize robotic operations for all. And this is exactly what we're going for. So thank you so much. I'd love to, answer any of your questions.
Hi, Nishant.
Hello.
Thank you for an amazing presentation once again. So I have a question for you. I mean, maybe probably eventually in the next few minutes or something, is it possible to see a snapshot of your software in operation? Or a video, you may be having a video or something. One second. Put you on mute.
Yeah. So just give me 1 second and I'll share the video. That's a definitely great idea. Imagine all right, guys. Can you see my screen?
Yes.
Okay. So I'll just let it run.
But we can't get the sound.
Oh, really? Just 1 second. Is it now? Is providing support to this through the digital infrastructure. Through an established workflow, Urus digitizes the end user, authorizer, and executor's journey to engage with any order. The end user can simply book any service that needs to be executed by an unmanned system. This order is then sent to the authorizing person, in this case, a pharmacist, that confirms the order, allowing for absolute digitalization, transparency, and record management required to run an actual real-world use case. This confirmed order is then sent to the operating team responsible to provide the end logistical solution sitting in a ranch. This team has the capability of Urus's cloud ecosystem, bringing every possible data parameter under a single umbrella. The order is then allocated by this team to the nearest ecosystem. A pre-flight data thread is created by the backend team to make sure that only the available and up-to-the-mark components become part of this mission. Continuous real-time data analytics allows this team to optimize the performance of the complete operation. The ground team then preps the aircraft for the mission execution. The order, including the required component, information automatically appears in the pilot's schedule. The Urus control and commanding platform enables the pilot to perform multiple missions simultaneously, providing all the real-time information. The pilot, already commanding 4 drones, gives the flight command for the current order. The video streams and real-time weather data enables the pilot to have proper environment awareness while also bringing the UTM data directly on this layer, providing complete understanding of the airspace. Log files and sensor data are stored on the cloud for any future reference. Our drone is now ready to take off. The platform provides custom SOPs for the pre-flight checks that are stored in the cloud as well. The pilot can now visualize everything happening with the drone on the control software. As for the remote supervisors and managers, the real-time parameters are sent to the cloud for complete understanding of the backend team. The drone completes the mission and lends to deliver the product to the medical professional. The order can be easily tracked and moved to completed status, where the backend team can understand the status through data analytics and visualizations. A post-flight data string is again created by the backend team to register the response. Majority of this data is autofilled using mission parameters. Backend team can now manage each component and access specific data like log files, workload distribution among pilots, drones, as well as battery discharging cycles automatically on the platform. The platform also allows absolute transparency to know about all the team members that are live at the moment. After the operation is done, maintenance team kicks in to make sure everything is in great shape, ready to go for the next mission. The Vurious platform provides a quick summary of all the aircrafts. It automatically counts the threshold values to alert for any overshoots. The maintenance team can access daily operation reports, individual drone reports, past inspections, as well as incident reports. The platform also digitizes the data gathering and report generation for complete operation. Not just drones, but even landing pads, batteries, and other critical components can be taken care of. As for the live video awareness for the remote supervision team, Vurious allows cloud video streaming. Come democratize unmanned operations with us. We are Vurious. So yeah, that's it from our side.
Pretty impressive. We have a question. We have two hand raises, one from Mayank. And I have another hand raised from conference system. Can I request you to please rename yourself? It's very odd to call your conference system. So meanwhile, Mayank, you can ask the question.
Hi, amazing work, Nishant. I mean, it's really nice to see all that you've achieved, and I think the value is solid. It's really there. Couple of questions on my end. I see that you've built a layer of hardware agnostic stack, wherein you can support all these different autopilots and all as well. I was thinking from the operations perspective, how agnostic is your overall pipeline to operational issues or like constraints, like say the lack of high bandwidth internet connectivity? Since you mentioned cloud features, is there a way that you could imagine your pipeline not suffering and you disabling certain feature sets when you're in an area which only has say 3G or 2G coverage, as opposed to requiring high bandwidth on-prem data streaming?
Right. This is actually a really great question. The first thing we had in our mind was to, create a very truly hybrid setup, which we call it. Every single data parameter that becomes a part of a cloud first becomes a part of the node on which our software is running, right? So, I mean, even if you don't have internet, we never limit your operations altogether, right? Every single data set that is stored on the cloud can actually be stored just on your computational device. And once it is within internet, it can basically start dispatching everything up in the cloud. The only thing that you won't be able to do is maybe see what's happening live. But when it comes to compliance and all the data parameters that you would want to be part of your existing operation, all of that will be there.
But then do you have support for, say, okay, let's say it's not a network constraint, but also data privacy concern that some operators have and they want on-prem data? Can you run on like a local cloud or a local server instance, which they might have on site, just for argument's sake? And like you mentioned that maybe at the time they cannot, they have access to live streaming, but if the platform that they choose to do their operations on has the memory capacity, could you perhaps have support for fetching the footage after the mission to support the insurance use case that you were talking about?
Right. So two answers to the questions. The first part that you said, if we can actually allow someone else to host their own data within their own servers, then yes, they can do that. We can definitely route it specifically for their servers. We are actually doing it for a few defense use cases. The other part of the questions, so we never store your videos or photos on our server, right? We only stream them. And if you want to store them, then yes, you can store them in your computational device as well. So it will be stored on your drone as well as on the system that the video is, getting through to the pilot. So yes.
Nice. And one last question I had was, you spoke a lot about democratizing fleet management and like using this. Have you considered, or is there a roadmap for contributing back to the open source community in terms of a limited feature set or in some way or shape or form?
Absolutely. Absolutely. I think we are learning a lot, working with enterprise clients, and there are specific things we'll definitely, want to give backwards to the community that they can utilize within their own, workflows. Then definitely yes.
Cool. Thank you.
We had one more question. I'll just ask the person. Meanwhile, can you please tell us how to get into your drone flying simulation app?
Right. So it's pretty simple. Just, touch base with us and, we'll make it happen. As simple as that.
Just a minute. Who else had a question? Can you do a hand raise, please? Sandra, you had a question?
No, I was asking Nishant whether he has like a link to the simulation app or a link to the website, maybe.
Sure, I'll just type it in.
Prabhat Singh, I've unmuted you. You can ask your question. Prabhat, are you there? Not sure. You have a question, Prabhat? You wanted to ask something? Okay, no problem. So any question, you can put it in the chat, and I'm sure Nishant will be happy to answer. Nishant, I'm putting that message into the everyone group.
Sure.
All right. And thank you so much for once again coming and enlightening us with your amazing case presentations, and work that you've been doing is superlative, actually.
Always.
And I really hope that everyone benefits from the kind of platform you're building for all of us. And in the future, I'm sure that we will be able to make maximum use of it, because that's the kind of complex operations we visualize the world to be moving into. And I wish you all the best.
Thank you so much. Great talking to you all. Thank you. And feel free to reach out.
Yes, please.
Thank you so much, Nishant, for your presentation. I'll move ahead to introduce our next speaker. Our next speaker is Sam Twala, and he is the founder and managing director of Nsu Aviation Solutions, all the way from South Africa. Nsu is he's going to present to us the use of drone technology in medical health, in the medical health sector in the African continent. And the presentation is mainly going to explore the use of the drone technology in the African continent within the specific focus of the health sector. And it will also be able to explore the use and case in the context of the African continent, and explore other topics as the status, benefits, challenges, and the different uses of the drone technology in this sector. I'll hand over the floor to Sam Twala to take us through his presentation.
All right, fantastic. Hello, everyone. If you could just confirm that you can hear me clearly.
Yes, we can hear you.
Oh, fantastic. Thank you very much. I will share my screen now. All right, if you can just confirm you can see my screen.
Yes, we can see your screen.
All right, fantastic. Thank you very much. Thank you much for the introduction. As introduced, my name is Sam Twala, founder and managing director of Into Aviation Solutions and Into Drone Academy. What I would like to do before I start with my presentation, I just have this video, it's less than a minute. If you can just take a look.
Is there a sound to it, Sam? Because we can't hear it. Sam, does your video have a sound or is just the video?
All right. Fantastic. Thank you very much. I will talk about that video in a second. Maybe let me start here. Just a quick introduction about myself. By training, I'm an electronic engineer, and then I also did a master's in aviation with Massey University in New Zealand. And just briefly, I did a little bit work in engineering, in electro-optics. And briefly, that would be about 4 years or so. I worked for Civil Aviation Authority, South African Civil Aviation Authority. First 2 years as a certification engineer, and then the last 2 years as an unmanned aircraft systems specialist. I also have a bit of an experience in a traffic management system as I worked as a senior communication and navigation, navigation surveillance system at Air Traffic and Navigation Services. While I was at Civil Aviation Authority, I had a privilege of participating at two most important international forums, if I can put that way, in drone technology. One being International Civil Aviation Organization, and the other one being JAROS. That is back in 2013 until 2016. All right. So the video that you just saw now, this was the very last flight that we did for Civil Aviation Authority. My apologies for the video. The quality of my video I see is not so perfect. That was a last flight when we were demonstrating the capability of blood deliveries to the Civil Aviation Authority, because I worked together with South African National Blood Services when they were pioneering this project. They've been in this project for quite a while. They only managed to get their certification very recently, a few months ago. Now, the significance of this operation, or at least the certification through Civil Aviation Authority, it was quite important because this was first in the country, right? This has never been done before. And never been done, I'll be combining two things, one being a drone delivery, secondly being applying or using drones in healthcare. So because this was the first of its kind, the eyes that we had on this project and the level of attention from the Civil Aviation Authority to make sure that they go through this project and make sure that everything has been looked at, all the risks have been considered, and then they've looked at all those in detail. So what you're looking at here, those were the images that we took throughout the process. So just want to do this way. Sorry about that. There's a little bit of a background noise here. All right. So the drone itself is able to carry about 4 units of blood, and the travel distance that has been approved for now is drone can operate up to 12 kilometers. And what was quite interesting was throughout the process, there were more than 10 inspectors who were involved in this project. And the reason being, I would actually call this project one of the first, or let me say, when you look at aviation risk, this application has been, I would put it up there as far as the highest risk that you can think of in aviation, in a drone application, simply because of the type of, the kind of distance, and then the area where the application is in a built-up area. And then the type of airspace, luckily where we decided to start was outside of a controlled airspace, to at least make sure that the risk to other airspace users was minimized to a greater extent. So that's where we started. Then maybe just to talk a little bit about ourselves as Aviation Solutions, we started, or as a company where we started, we were in consulting. That would be the compliance. And secondly, when any organization, they're looking at getting into drone technology, one of the biggest challenges that they would have is once you get into drone technology, one way or the other, you are getting into aviation. However, most people who get into drone technology don't really have much aviation experience, and they need someone to hold their hand and be able to understand their requirements, understand their technology, understand what's the intentional, what's their use, and then be able to translate that into aviation language. So that's what I've been doing for more than 4 years. And then we also got into a drone operations management tool. The reason for that is it's time where we now need to digitize how we do things. To a greater extent, where the industry started, we understood things from a manned aviation point of view, and there's really little digitization, including automation in manned aviation. And for drone technology to work efficiently, we need to move as far as we can in digital airspace, in digital space. And then we also involved in selling drones, including training that would be training of pilot qualification, which is one of the requirements, at least in South Africa, for one to get involved in commercial operation. And to date, we have delivered about 25 ROCs. ROC, that would be your ARPA's operator certificate, which is a license that you need for one to be able to operate drones commercially in South Africa, and we have about 24. Maybe just to give you an idea, all in all, we have about just above 90 operators which have been approved. And what we managed to do as well is we managed to assist the first government department to get their license, which is the Western Cape Emergency Services. And if you look at the type of work that they do in Cape Town, especially in Table Mountain, it's been unparalleled. Including the municipality, we managed to get the first municipality through the process, including the medical deliveries, which is what I was talking about. Now, the reason why I'm highlighting this too is what I see quite a lot in South Africa, including most African countries. What you see a lot would be the drone technology adoption in private sector. It's been on quite a good trajectory from the beginning until so far. But for some reason, one way or the other, in government departments, there's always a talk of the benefits and the use of drone technologies, but the uptake within the government departments, for some reason, it's quite slow, which is something that sometimes, really surprises me. Now, what I would want to highlight with this slide is this concept. Back in the days while I was still at ICAO, which is International Civil Aviation Organization, in 2013 or so, there's always been this notion and this saying that the drone market is expected to grow faster in Africa than in any other continent across the globe. And then if you look at the image that I have on my slide here, there's that projection, the growth of drone industry, like between 2018 and then 2025. And you can see the difference that the growth is quite significant. To a greater extent, you can go as far as saying almost 4 times, right? But the question that I always have is, in real value, in real benefits, you know, in African continent, are we really exploiting or exploring drone technology and reaping benefits as we supposed to be, as everyone else has expected that to be? And the question to that is, well, the answer to that question, to me, it's not so straightforward, it's not so clear, but in my mind, we are not doing that. And one of the biggest challenges why we are not able to do that is, I explain it with this slide, where I say there's always this conundrum between drone regulations, operations, and traffic management, right? Where you'd have your concept of operation on the left, and then in the middle you have your concept of regulation, and then on the right here at the bottom right you have what I call traffic management. Now the key, it doesn't really matter exactly where you are in it. How do you get to harness and benefit as much as you can from drone technology? That would be if your concept of operation, your concept of regulation, and concept of traffic management, there's harmony between those 3 pillars. And harmony, what I mean with that is what the industry is attempting or trying to achieve with drone technology. Regulations must be in a position to enable it. But just saying enable might not be adequate, because the regulators, they also have a duty, they also have a mandate, which is regulating the use, regulating in aviation to make sure that whatever aviation activities that we have, they are done safely. However, then on the far right, you have traffic management. The bottom line is, of which we may have debates and questions to say, you have air traffic management in a sense of traditional aviation, and then we have unmanned traffic management. That conversation has always been there, but how I would like to look at it at this point is, we have one airspace, and drones need, one way or the other, they need to have access to airspace. And how you get to access the airspace, that must be enabled through regulations. And that need to access airspace in a certain way, certain time, in a certain time, within a certain period, you know, that will then be dictated by how people want to operate drones, which is the concept of operation. So which is why I was saying there must always be that harmony between what the industry is looking for, what is it that they want to do. Regulations should be able to enable that to as great as much as possible, and then the access to airspace, it must be possible at the same time. When it comes to regulations, there has been, progress to a greater extent across the globe, and the most progressive way of regulating drones has been to come up with categorization that we see a lot in European countries, where there's open categories, specific and certified categories. And the reason for that, for coming up with this categorization, started from the fact and the idea that regulating drones cannot follow the very same principle and concepts as how manned aviation has always been regulated. The most important approach or change or shift in thinking is, with the drones, the regulation must be operation-centric. Operation-centric regulations must be operation-centric in the sense that you are looking at aviation risk, and then you regulate from the risk. If this operation poses little to or negligent aviation risk, the amount of rules and regulations that one has to go through until they get the approval would certainly be different, or should be different, compared to the operation where the aviation risk is high. So that's what is the basis of that categorization. And then with concept of operation, the most important thing is drones, number one, are not equal. Two, you could have one and the same drone. However, the application could be different, right? Using the very same drone. Right? So that's that's where the complexity, as a matter of fact, starts from. Right? From the operators, they come up with innovative ideas every day. They and innovation, the pace innovation in drones is very quick. But so what I indicated earlier, that there must always be a harmony between what industry is intending to achieve, the regulations, including the access to airspace. It means when the technology advances, it gets better. Regulations must do the same. The means to get to access to airspace must be the same. So harmony must always exist. Now, this is one of the picture that was drafted at ICAO years ago. Yes, it's a little bit different now, but the reason why I have this one here is because it's a little bit dramatic, in a sense that when you look at traffic management architecture, there's a lot that is involved, right? You would have your operators, you would have your supplemental data service providers, that whether that be your weather data or your ground hazards. Then you have your traditional NSPs, right? That would be your traffic and navigation services. Now, the significance of this slide, I'm not trying to get into it and try to explain this slide, but what I'm trying to explain or take from this slide is the air traffic management can be complex, can be very complicated. But what becomes very important is you, as maybe let's say a particular country, you're not going to try and take this structure as is and try to do copy and paste. What is important, the implementation, how the access to airspace will be managed will differ from one country to the other. The reason why it will differ from one country to the other is because drone use and drone uses differ from one country to the other. We don't have one size fits all as compared to main aviation. You will find that for some countries, you would need a relatively complex operation to facilitate the access to airspace. And then there are those countries where, if you compare with manned aircraft, the activities, the movements might be much, much lesser, to a point where the air traffic management could be defined as just connecting with air traffic controller through a defined means, which might be as simple as you have an application that's running on your cell phone, you make a request to air traffic controller, they give you an access, and then you continue. Whereas you might find that in a very complex airspace, right, that might not be adequate. Depending on where you fly, right, that will also be quite important. So in closing, the most important things that I would want to mention in this stage is enabling regulatory environment. It's very much important to make sure that we harness the use of drone technology and make sure that we reap as much benefits as possible. And that can only be possible if there's an enabling air traffic and management system. And again, the most important element is the importance of public and private collaboration. This is super, super important because you may find that when you work with government departments, one of the most important important stakeholders here being Civil Aviation Authority, including air traffic and navigation services, to be able to put up the infrastructure, it may tend to be quite an expensive exercise. And to a greater extent, over and above that, the mandate that they have, you're adding drones. And we all understand that drones come up with different complexities and different requirements. So it becomes quite important as well that there's that partnership to make sure that there's a balance, especially when it comes to being able to make sure that we end up with the best solution. And then a need to digitize drone operations. For drones to be adopted in numbers, it's only possible if you are running on a digital platform. And then one thing that I must say, which is quite obvious at this stage, is that drones play a major role in the next industrial revolution. And the coordination between different government departments, super important. Whereas previously you find that drones or aviation has always resided under Department of Transport. Whereas when you look at where drones are used today, they're used in almost any industry, which now it means when you look at the national policies, you look at how to integrate drones. The conversation extends beyond Department of Transport. And then obviously the most important thing is a clear national drone agenda. You may find that what is of immediate use and need in South Africa, it might be a little bit different to all other neighboring countries and any other countries across the globe. So each and every country is quite important that you have your own national agenda. That's what I call it. And then preparing obviously for future jobs today, that talks to data-driven industries, and that may talk about there has a strong reference to training and to that extent. And then with economics as well, we're now looking at new way of doing things, which then talks to new jobs, new opportunities, and then benefits. And then one thing when it comes to drones, as is now, it's a fact that the drone industry is yet to attain mass adoption. We are just at the beginning. Things are going to get better and better as time goes on. Thank you very much. That would be all from my side at this stage. I'm not sure if there might be any questions.
Thank you, Sam. This was an amazing presentation. You are again. Hi. So, Sam, I would like to know from you, how is Africa as a continent and South Africa in particular opening up for such kind of BVLOS operations, and how is your company playing a pivotal role in it?
Just repeat the last part. Just missed the last part.
How is your organization playing a role in ensuring that Africa adopts drones for BVLOS operations and for complex operations?
Okay. All right. Thank you. That's a very good question. One thing that I must say, and I will applaud the Civil Aviation Authority in this instance, there's not even, there are no restrictions or undue limitations which are within the regulations as far as beyond visual and offsite. And the approach has always been, there's no limitations within regulations to say you can fly up to this point. Regulations are open-ended in a sense that if you want to fly up to 10 kilometers, you need to then approach the regulator and say, I'm going to fly up to 10 kilometers. Here's my risk assessment, and this is how I'm going to do this safely. If you want to fly up to 100 kilometers, you would be able to approach the regulator and say, this is how I'm planning to do it. Here's my safety case. This is how I'm planning to do it safely. And if you are able to convince the regulator, you are able to get your license with BVLOS.
Great. And how do you see the Africa market in terms of the BVLOS drone projects like deliveries, and how do you see the ecosystem being ready for it? You spoke about regulations also. So do you think regulatory hurdles are still there and they need to be overcome somehow?
Yeah. Regulations are quite tricky and difficult, I must say. And the reason being, from the regulator point of view, it's quite difficult, almost impossible to predict all risks which are involved in drone operations, which is their number one mandate as a regulator, to be able to make sure that drone operations are safe. So because it's almost impossible to predict and know the risks which are involved in operations, that's why the approach of present your case and then let us approve based on your approve. Now, when it comes to drone deliveries, in one of my slides that I've indicated, it should be a common, or it should be an understanding, not even a point that we need to debate, that when it gets to African continent, where sometimes you may be dealing with challenges when it comes to access, or the sparsely population. So it makes sense that drones will be a solution. Drones will make things much easier in that sense. So when it comes to long distance operations, when it comes to deliveries, I see that growth that is yet to happen, that is yet to come.
Thank you very much, Sam, for being a part of a conference. It was a pleasure hearing you. It was pleasure understanding your perspectives about different things that are happening. And yes, we really hope to continue engaging with you and learning from you in the future as well. Thank you for being a part of our conference.
Thank you very much, and thank you for inviting me.
You're most welcome.
Thank you. Thank you. Bye.
Sam, you need to stop sharing the screen. Yeah. Sandra? Sandra, would you like to introduce our next speaker?
Okay.
Hi, Sandra.
Thank you so much. Thank you so much, Dr. Ruchi. Our next speaker is Sant Satya, all the way from the United States. And he's going to talk about hydrogen-powered autonomous air and road eVTOL flying car. Sant Satya is the founder and is a founder and CEO, and is the founder of Car, an autonomous air and road mobility eVTOL mobility company since March 2021. And he is also the CEO of Car and serves on its board of directors. Sant deeply cares for the environment, sustainability, and the relentless innovator of technologies that solve complex problems, improves lives, and builds social equity and fuel progress.
Thank you very much.
Sant, I would like.
Go ahead.
I would like to give you the floor. You can go ahead with your presentation.
Thank you very much, Nadula. Appreciate the introduction. And thank you, Ruchi, for inviting us for this event. We're deeply honored. And I'm glad to be here with the rest of the folks. So I want to talk a little bit about our invention, our concept, and how it applies to the air mobility industry and how it intends to transform the way the air mobility industry is evolving. So we are, our primary goal is to democratize travel. And let me share my screen here so that I can walk through my presentation. So you're able to see my screen? All right. So Car is trying to create a bridge between the road to the skies. It is an age-old dream for humanity ever since we took up flight. And it's the ability to fly and drive. There have been so many concepts that have been shown in movies, and there have been so many attempts in the past to bridge both modes of transport. And I want to show a quick 1-minute video before I talk about the problems that we are solving.
Well, if you ever plan to motor west,
yeah, sorry about that. Let me play it again.
well, if you ever plan to motor west, Jack, take my way. It's the highway that's the best. Get your kicks on Route 66. Well, it winds from Chicago to LA, more than 2,000 miles all the way. Get your kicks on Route 66. Well, it goes from St. Louis, Joplin from Missouri, Oklahoma City looks so pretty, you see. Amarillo, Gallup, New Mexico, Flagstaff, Arizona, don't forget Winona, Kingsman, Moscow, San Bernardino. Won't you get hip to this kindly tip? Jack and take that California trip. Get your kicks on Route 66.
All right. So you've seen the video. The problem that we are trying to solve is that today, as of door-to-door delivery is concerned, the drones deliver smaller packages due to payload limitations from battery power propulsion. The batteries are heavy. They cannot really lift very high payloads that's needed that we normally do in cargo, in road cargo. And then once you deliver, you're able to deliver it only to one single destination, and then you will have to need a warehouse. So it increases logistics cost. So we are trying to solve the door-to-door delivery problem by providing this roadability capability. So what we would eventually do is take these cargo and land in a vantage point, and the road vehicle will detach and go door to door and deliver. So that way you can provide services to people at their doorstep and take payload larger quantities up to 1,500 pounds payload. And also, there is really no multimodal transport right now for disaster relief. There are places where you cannot land in air. There are also places where you cannot drive. But with having a vehicle that can do both, you can land in places, in vantage points, and you can drive to the site of the incident, and you can provide disaster relief. And pretty much what we are trying to do is give faster solution, give faster delivery of, give a faster mode of transport, and help people get their services done at a faster rate by providing wings to your car, wings to your cargo truck, wings to your transport bus. And also only 2% of people travel across the world for distances less than 500 miles by air, because air travel is very expensive. It is not democratized. And once you reach your destination, you still have to rent a car. But imagine you having the ability to fly your own personal car from point A to point B, and then having the ability to drive your car to point C. It solves, it gives you more freedom. And if you make that concept affordable, then it helps large sections of communities. People living in rural areas can fly into urban areas for work at longer distances, and they can go to their destination of work. So it helps create connections between communities. I mean, in a developing country, like say, for example, in India, you could imagine people flying from a city like Bombay to a remote place, or a remote place to Bombay, and still have this roadability. And I'll talk a little bit about the concept of the business model as we go further. To talk a little bit about the technology, the air vehicle will be powered by hydrogen fuel cell. And why hydrogen? The hydrogen fuel cells have got 4 times the energy density compared to batteries. And they also enable you to carry larger payloads. It's going to be an autonomous flight eventually, because autonomy reduces the number of pilot-driven errors. And with the air highways being planned globally, we will be able to have good air highways connecting cities, and these vehicles will take advantage of it. We are working with FAA and also with the NASA we are part of the NASA working group in assisting building air highways, and we have our own proposals as well. The vehicle will have a 6 tilt rotor system with tilt wings on the sides, which is a recommendation coming from the industry experts. And also we have licensed NASA technology to develop the propulsion, the tilt rotors. We have the 5-point docking mechanism between air and the road vehicle is our IP. We have 3 intellectual property patent applications around it. And the docking mechanism is more of a 5-point linkage that is sensor-based. We have won quite a few awards, and we are working with the defense. We are trying to get some defense contracts in that. There's a lot of interest because this vehicle would be a warfighter vehicle. And we have formed MOUs with airports, because the airports will be the places where hydrogen will be made and in a distributed manner. And there will be the places where hydrogen can be refueled into the vehicles. The hydrogen that's being made in these locations, and I'll talk about these Luftpad concepts where hydrogen would be available, will be a unifying factor between aviation, road transportation, and utility power. We have a strong team. We all come from the industries. I myself had worked at Ford Motor Company, developed 300 hydrogen fuel cell cars in the past, and we have people coming from Lockheed Martin and McDonnell Douglas and large organizations from the aviation industry. We are the only concept that's got the air and road capability. I want to talk a little bit more about the application itself, because that's what you want to be, you are interested in. The air and road mobility helps build equity in the society. For example, there are only 20% of the population across the world in the United States, 20% in the United States have access to immediate air travel. They'll have to drive long distances to go to airport. They don't have access to quick air cargo because cargo delivery is limited by freightways. And by creating an air cargo industry that is affordable, where you don't have to pay too much for cargo to be delivered in air, you are connecting these large communities in delivering medication, food supplies, and also essential items, and also bringing doctors to them, bringing healthcare to them. And not only that, giving them the ability to commute to work for larger distances. So we are democratizing travel. The key idea is to reduce the cost of travel in these vehicles. Our calculations show that the cost per mile would be 60 cents to 80 cents per mile, per car seat mile, which is slightly more than an Uber charge. And as for cargo delivery, it will be like $7 to $8 per 1,500 pounds per mile. So which is again 1/5 the price of a helicopter air cargo delivery. So we are reducing the cost by improving the affordability and serving large sections of the society. For its time, automotive, it took a while for the car industry to be democratized. So now many people can afford cars, but now we are making that effort in the aviation industry. And by providing this dual mode approach, the dual platform approach, we are able to provide the end-to-end delivery solutions. So that is pretty much around the application. I want to talk a little bit about the hydrogen lift pads. Now, hydrogen is going to be the unifying factor for our energy solutions as the world is moving towards the hydrogen economy. We are partnered with airports, hydrogen producers, and hydrogen storage manufacturers, and we have our plans are to install the hydrogen refueling facilities in airports and also in large parking lots where lift cars can land. We don't need too many lift pads across, like in other business models where they need vertiports very often. We need lift pads every 50 miles radius to give you that sustainable mode of transportation. And that's where it is. Let me pause now and let me open up for questions. Thank you.
Thank you so much, San, for your amazing presentation. Can we have questions or hand raise if you have any? San, you can stop your presentation so we can put in the spotlight. Great. Yes, so we have a question from Sunil. Sunil, you can ask your question.
Actually, I was so fascinated how this car has been lifted by the wings. So maybe one question would be is it possible that there would be a folding wings or so it can be put and somewhere if we go and again we can unfold that and can travel with that? Is it possible? Have your team also thought on this? Did you get my question? I'm not actually hearing you. Maybe you are on mute.
Oh, there you go. I'm
Okay.
unmuted now. Yes, that's a great question. And many companies have tried the foldable wings idea. But when you fold wings, you're carrying that extra payload along with propellers into the urban environment. And that is a big burden penalty on the energy. So what we want to do is not change the way people drive around on the roads. They don't need to tow along very heavy package. I mean, energy comes at a premium. The way you reduce the cost is to keep reducing the weight. So once you detach, you can leave the airframe behind. You can drive in the car. We can fold the wings. That has been done before, but I don't think that will be a good commercial model. And the other thing I forgot to mention is that the wings are rentable. So you only own the car part of it, and then you go to the airport or your parking lot where these lift pads are, and you rent the airframe. You can fly to a destination, leave the airframe behind, and then drive your road vehicle. So that way you don't really need to own the full vehicle end to end.
Oh, wow. So there is another question. How much payload would be lifted by this hydrogen fueled vehicle,
Right.
I would say?
Right now, the payload is limited by the electric motors that is available in the market. So we are right now proposing a payload of 1,500 pounds maximum. Now, our closest competition has designed vehicles that will carry 1,000 pounds, but we will be at 1,500 pounds. But at the moment bigger motors are available in the market, we can always scale it up. And also it depends on how much hydrogen we are able to pack in the airframe. So we are starting with 1,500 pounds, but we can scale up all the way up to 2,500 pounds eventually.
Okay, sir. Thank you.
Thank you.
Hi. So I'm really it was impressed with this, and I really want to learn more about this. So it was a wonderful concept. Okay. So I just wanted to know about two things quickly, and that is you have said the reduction of cost, with the current market scenario, it will be costing less. Then is it as per the current infra and regulatory demands, or are you calculating on the basis of future respect to the future availability of infra, like ports? You're going to need storage, maintenance, and manpower. And is there any such facility right now in United States or any other country which is having such concept of maintenance and holding those wings and all that required stuff? Thank you.
No, good question. Good question. The cost, the numbers that I shared, the 60 cents and the $8 per kilogram per $8 for 1 mile cargo is all based on a 3-year outlook, right? There's no infrastructure right now. Right now, we are all working on the infrastructure designs. We are working on the regulations, right? Particularly for hydrogen. So the numbers that I shared is based on the conversations that I have with my technology partners, the cost roadmaps they show, the cost roadmap for hydrogen as a fuel carrier. So based on 2 to 3 year outlook, that's the numbers that we show. So when we commercialize in 2025, 26 timeframe, those will be the cost numbers that will be hitting. But as we go into 2030, the cost will go down further, hopefully, because there'll be a lot more infrastructure options available.
Thank you.
Ashwini, sir.
Hi, Sant. Very exciting prospect. Quite appreciate the concept and the design. My question is the hydrogen motive force for everything in that vehicle? That is for the car which will drive on the road, as well as the it will also generate power to move the electric motors for the copter?
Yes, primarily the hydrogen would be for the airframe, for the motors in the air vehicle. For the car part of it, we are agnostic. It could be either a hydrogen fuel cell or it could be batteries, but the range for the car is around 150 miles, not more than 150 miles. So we are planning to put just a available lithium-ion battery for now, but we could eventually put a fuel cell. But the fuel cell, hydrogen is primarily for the air module. That's what gives you the range.
Yeah. So in other words, the hydrogen, I mean, if it will limit your range for the airframe if you use it also for the car, right?
Yeah, well, battery is a lot heavier than a hydrogen fuel cell. So the more I can go to away from a lithium-ion battery, the sooner I can do a lightweight battery or a hydrogen fuel cell, that's better. But right now, that's not the main problem that we are trying to solve. The main problem is to develop a hydrogen fuel cell propulsion for the airframe. But you're right. I mean, yeah, the weight is a very big factor for the road vehicle. Yes.
So you'll have to have a trade-off between, how much to use for which. But being a fuel agnostic on ground would be a good idea. I mean, I would suggest while moving on the ground at least. Yeah.
Absolutely.
Thank you, son. Excellent presentation. Thank you very much.
Thank you. Sure.
Then we have a question. What is the height at which the lift car can fly?
Yes, the height is dictated by the aviation regulations in that region. In the United States right now, we are targeting 4,000 feet. Sorry about the metrics and units that I'm using, but I got so used to it. The 4,000 feet altitude is what we are targeting because anything above that goes into the commercial space. But going back to this earlier question that Abhi asked, eventually in future, they might bump up the commercial space for advanced air mobility. So we might go up to 10,000 feet. So anywhere between 4,000 feet to 10,000 feet is what we are designing for.
And that altitude is manageable with the current design of lift car, or you see it improving later?
That's right. So I don't see these things going beyond 10,000 feet. Then it kind of, we are going into this large commercial airlines space. But our design's pretty much for that big range.
Great. Thank you so much. Okay. Any other question do we have? Anyone would like to ask? You can just do a hand raise or a thumbs up or something like that. Okay. I guess no.
Yeah, I apologize for being a little bit rustic in the morning here. I mean, it's like 6 a.m. and
you're perfect. You're absolutely perfect.
Now, my opening could have been a lot better, but I hope we understood the concept, and we are trying to create a global market here. We are getting a lot of interest from all the way from Australia to Japan to the United Arab Emirates and in South America. But it's
not India.
Well, we are talking to a large audience here in India, so that I do get that a lot as well. I'm just talking about the boundaries here, but the onus is on us to develop this first prototype, which will be available next summer by June of 2023, and then we will have a flying model to show to the world.
So how do you see economics working? For example, comparable to the existing transports, do you have some metrics like if we have to propose, would it be cheaper? Would it be expensive?
Yes, good question. We have to make this cheaper, and our target is the $60 to 70 cents per car seat mile. That's pretty much what you pay for Uber right now. Maybe you're paying like 50 cents per mile for Uber, but this will be a little bit more than Uber. But as the hydrogen cost comes down, the cost for travel is going to go down as well. So that's the scale of economies here. What we hope is that with the infrastructure being available, this aerial mode of transportation for normal people, for regular purposes, will become more prevalent, that you are not held hostage to the airline logistics at this point in time. So as you remove the logistics hurdles, it's going to be a lot easier for people to travel from point A to point B, and vehicles like these will help the cost come down on a daily basis for an average person.
And what kind of partnerships would you seek which will help you enable whatever you are desiring for?
So we have three industry verticals that we are targeting. On the cargo side, our partnerships would be with the cargo vehicle developers, cargo consumers, like customers like Amazon, UPS, and cargo, and also businesses that deliver large cargo. We have a purchase order from a cargo delivery company in United Arab Emirates already, because they are seeing huge value in this. So that would be our customers and partners in that segment. When it comes to the hydrogen part, it'll be the hydrogen manufacturers, anybody that does any equipment work in hydrogen, and also the governments, like the county, state, regional governments that would have partnerships. We are right now working on a partnership with one of the states in India. I'm not allowed to disclose that yet, but also we have a strong partnership and sponsorship from a couple of county governments here in the United States. A couple of state governments are interested in us. That we have support from one regional government in Germany. So the governments play a big role in bringing these vehicles into their airspace. And other than that, the military, the defense of that particular country would also use our vehicles for being part of their disaster relief.
Great, that sounds amazing, and that sounds promising. That's something that we should all be looking forward in the next decade or so. And hopefully it will change the way we work, the way we live our lives.
Thank you very much. I look forward for your support and for your following of Liftcar.
Thank you for being a part of this conference, and we hope to keep learning from you in the future.
All right. Thank you. See you.
Thank you. Bye-bye. Abhi, would you like to introduce the next speaker?
Okay. I want to introduce Jamar Williams. He is a creative entrepreneur who specializes in innovation and integration, and is the founder and CEO of the world's first two-way digital display aerial drone company called Promo Drone. Currently, Jamar is just a second. I had difficult this issue with this. Okay, Jamar spends most of his time developing Promo Drone's business operations and scaling the company's emerging infrastructure with an emphasis on public safety. The company's new beta platform will be ready for public debut in first quarter of 23. That's going to be like in Jan to March of next year. So yeah, welcome, Jamal. You can carry on.
Yes, thanks for having us. This is awesome. Thanks, Dr. Ruchi. As they said, my name is Jamar, I'm CEO of Promo Drone, and we're doing something a little bit different. Based here in San Diego, California, and what we're doing is we've created drones with digital displays for outdoor engagement, whether it's advertising, public safety, or anything in between. But what we're going to talk about today is something a little bit different. We're going to literally talk about how do we get the community involved and supportive of all these concepts that we have. When I first started flying drones, I realized there was a huge disconnect between everyday people and us with our brains that are so, hypnotized by this cool technology that sometimes there's a contrast, right? So it's our job as these innovators to make sure that we can survive and thrive with our technology, not just from an innovative standpoint, but also we need the community's buy-in. So what we're going to talk about today is how do we bridge the gap between our innovation and the people that we want our innovation to serve. So let me get in here. Let me start the presentation. Okay, so public perception of drones. When I first started flying drones, probably very like a lot of people on this call, there's a lot of fear, a lot of skepticism, a lot of doubt as to whether these things were going to have value. So we're going to talk a little bit about where the public perception is today, what's the reaction likely to be to drones in everyday life, and then how will the public be accepting of the landscape that we're trying to change. We're talking about building smart cities, having drones flying around in everyday life, from everything from deliveries to public safety. How do we get people to buy into that? Well, one, we know the market's shifting. We all know that we're in an area where the growth is happening very rapidly. But with rapid growth, requires flexibility. It requires support. It requires our ability to use our technology for good in a way that's going to have an impact in community from a real way that's going to allow them to see the benefits. So when we're thinking about how do we get past that tipping point? When I started the company, we initially started with the focus on advertising, using our drones to fly around big events for brands, promotional opportunities. Think large outdoor concerts where any drone pilot can monetize our platform as an independent operator, an entrepreneur, and now they're making a career, they're making their own money, enhancing their quality of life through these outdoor drone experiences. But as attitude is split, some people love drones, some people are a little bit confused about what they do. What I realized is that drones for good is really the glue that's going to help. When we're talking about how drones can save lives, it's directly contrast to their perception that drones are going to be constantly properly misused. The questions we get a lot is, what happens if these things fall out of the sky? What are you going to be spying on us? What happens to our private and sensitive information? And these are all valid questions, and we all have answers to them. But until it's adopted at mass, we're going to have challenges with this innovation. So what I've realized is, in the past, we focused a lot on creative content, real estate. Now we're exploring the eVTOL benefits. We're looking at how we can use drones in different ways. And what I've realized is, in order to change, how people perceive us, we had to be flexible. We had to pivot. And now we're working with organizations. We're targeting organizations like Department of Defense, FEMA. There's a lot of floods that happen. There was just one here in Jackson, Mississippi recently, where they're launching drones to survey water levels. Now in that same flood crisis, you can have a drone that's flying out, identifying an individual that's on a rooftop, having a digital display that's going to allow that person to know that help is on the way. And through a series of gestures, movements, or two-way feedback, now you're allocating resources more efficiently. So these response agencies now are reducing costs, boosting their force multiplication efforts, and saving more lives using technology that's designed to enhance these operations. When the public starts to see these things, when grandma's on a roof during a flood and now she knows she's safe, you're de-escalating those emotions, this allows the community to now see the true value and allows things like advertising, deliveries, and all these other things to really have a root, because it's a more personal and emotional connection to what the value of drones are. We have that, right? Because we are educated on it. We understand it. We're the ones doing the research every day as to how to make this stuff work. But sometimes we get a little biased, right? We're so excited about the fact that we have all this cool technology, but sometimes we forget that the public, they don't have any understanding of this. They're working their jobs, they're 9 to 5. So all they're concerned about is this going to be more of a nuisance than a benefit? There's contrasting views. We understand the value, but we know there's challenges on the regulatory side. So as we've come from an early stage industry to a little bit mature, we're still at its infancy. We're at that 1% out of 100% point, and over the next few years, we'll kind of grow and expand. It's important that we're using our drones in the right way, having consistency in our messaging, having the benefits be clear and impactful, and then working together in a collaborative nature to make the rules of engagement viable, so that we not only can have an economic viable path with it, but the community can also feel like they can entrust and start to use our technology in a variety of ways. Based on some research, search and rescue, observing fire spills, emergency services have a lot of buy-in from the community. So the more and more they see in the news, they realize that these drones are impactful, the more and more they'll be more accepting of these alternative uses for it, such as advertising and the like. So when we started our concept, we were like, will people look at a drone for more than just to yell at it because they think we're spying on somebody, right? And that was the birth of my idea. Could we put a banner on a drone, get someone's attention, and then use that in order to create a reaction? And it's grown from a simple banner concept with just a static banner on a drone to be flown at golf tournaments, volleyball tournaments for sponsor monetization, to now a beta platform that we're going to release in 2023 with full-blown focus on fire departments such as FDNY, Chicago Fire, LA Fire, FEMA, Department of Defense, and in everything in between, where we can train these EMS responders how to fly the drone and how to use it in these situations in order to enhance their operations. The future landscape, when we think about what it's going to look like. It's vertical in nature, right? And as well as horizontal. We're going out and we're going up. So this means that we have to have safety as a priority. We have to have technologically advanced products that are able to live up to the expectations of the consumers that will be using it. And because we're starting to take this approach, the sentiment is starting to shift. We're not there yet. There's still a lot of unknowns. There's still a lot of community education that has to happen. But what we're doing is the more and more the public's exposed to the benefits of drones, the more our jobs are going to be easier exposing them and bringing that innovation to market. So what's going to happen over the next few years is we're going to grow from these concepts. I know a lot of people here have wonderful ideas, but we're really at that prototype phase of things. We're testing the waters. Over the next few years, our products are going to be more solidified. They're going to be integrated at scale, not only in the United States where we are starting in San Diego, but throughout the entire globe. So it's not just going to be a local commitment, it's a global commitment. In order for us as a unified front to get past these challenges, these perceptions, this sentiment, we're going to have to make sure that we're doing positive things with the drones, letting them know that we're on their side. And even when there's instances where, the bad guys, so to speak, are using drones in a nefarious way, show that we are the ones that are supporting the positive efforts of it. So using drones for good, having advanced sound technology, really displaying the impact of what drones are going to have in the community is going to enhance our ability to buy in. It's going to